I'd like to welcome you to City of Odour Special Committee of the Whole meeting for Monday, April 29, 2019 at 2 p.m. We have only one thing on the agenda, and I want to acknowledge that we're holding this meeting on the traditional territory of the Pa'aman people. So with that, I would like to turn it over to Mr. Rittig.
Motion to adopt the agenda.
Right. I guess I'm just trying to do this too fast.
Third.
Councillor Humphrey, Councillor Mitchell, all in favor? Unanimous, thank you.
Just way too part
Okay. Some planning on sharing. Let's see if we got that. Yes, number 2, Associated Engineering, Mr. Brady.
Good afternoon, thank you, Chair, members of Council. What we would like to present to you is an update of where we are with the design of our consolidated treatment plant. You know that we submitted an application for funding for construction of this plant a number of months ago, but we're yet to hear a final decision on funding, and we're hoping that a positive decision is shortcoming. We've worked on the design elements for, it's been a couple of years now actually, and what we wanted to let you know is the state that we're at, show you what we've come up with the design of the plant, and the steps that we went through on our design process, the questions and answers, and you'll see how much detail that has been put into this, the elements of the design, the various components of this project. So what I'll do is introduce the members from Associated, and then we'll turn over the meeting to Associated to display the project, and if Council has questions along the way, then by all means ask them. So, we have up front that is going to be doing the driving and the show of our 3D design elements. It'll be Brett Webster sitting in the front. We have Michael Simon here. We also have Mark Porter, Jason Leung, and then Tom Robinson from Associated Engineering. As well, we have from Colliers, Tatiana Rozbadoska. So at this point, I'm going to turn the meeting over to Tom Robinson to go through where we're at with the design process.
It's good to be back. Welcome to new councillors. Your first chance to see the way things are taking shape. We're going to show lots of images today. It'll be a little bit different than what you've seen so far because at the earlier stages of the project, about a year ago, the images that we were shown were meant to provide a sort of an overall scape of the project. And those were very useful for that period of time, but we've now moved into the 3D design. And so the software package that we're using is much more specific and much more specific for creation of construction drawings that will be used for construction. I'm just going to give maybe the next slide, Brett, and I'll give you a little bit of an outline. Oh, I have it there. See what a needle-arch team. I have less than a full brain. Okay, so I also just wanted to make you aware on council that you can direct. We will accept direction as to how much of a certain thing you want to talk about. This is our suggestion, if you want to call it that. We're going to talk about the treatment plant design. Quickly review for the newcomers the rationale, the overview, the natural integration theme that was selected about a year ago by council. We'll talk briefly about the process, and then we'll take you through some of the design elements and walk you through some of the buildings. It's kind of impressive the way the design software lets us do that. But Jason Leong, who was introduced earlier, is somebody on our staff that tracks your conversations and your council meetings very carefully and very closely. So we know that plastics have become a big topic for you all. Microplastics, but I'm broadening the discussion a little bit just to refer to it as plastics, and also potentially touch on emerging contaminants, and I'll explain what that means. So we've set aside maybe 20 minutes for that kind of a discussion, but it could be longer if you'd like. And Mark Porter, who is our national lead of buildings, he handed me his title here, it's quite an exalted title. But most specifically, he's chair of Associated Engineering's Climate Change Initiative, and also chair of Engineering and Geoscientists BC Climate Change Committee. So Mark's here to help you, support you with your discussion of climate change. We can talk about how that relates to this project as you're interested, but we're really just here to support you on those other two topics. And then we'll have time for some questions. We may move some of the question time to the section after the treatment plant. So first of all, does that sound about right? Okay? Okay. So I'm going to try and tell you when we're getting close to the end of the agenda for the plant, so that we save time for everything else. We can go late. These folks just need to make it on a 5:30 flight. I don't like to stay longer. Okay, let's carry on. So again, why are we doing this? Why are we doing this thing we're doing? It's for compliance with federal and provincial regulations. It's to help you consolidate 3 wastewater facilities in their various states of function and dysfunction into one facility. It's to reduce the environmental impact, because that will be the net result. We're doing this to make the environment better, to improve human health, and to make your operations easier to operate and maintain and administer. What will it consist of? A new consolidated wastewater treatment plant. We'll have a new outfall and a diffuser system located off what I've called First Beach, which is just near the jetty, down the slope from the existing town site wastewater treatment plant. We're using treatment processes and equipment that are effective, proven, modern, and what we believe offers best value for the city. There will be 4 new pump stations, and there will be new conveyance routes, which means pipelines to move wastewater from Westview to town site, and also to bring Wildwood flows and connect them to the town site system as well. We will be decommissioning the Wildwood Lagoon, the Westview treatment plant, and the existing town site treatment plant. That's not a small part of the project, but it's not one that we'll be talking about very much today. So for newcomers that don't necessarily know these interesting areas of the city that I know quite well, this is the Wildwood Lagoon. So little, whoops, that. More. So this is the Lund Highway here, and it's off to the right. You don't really see it unless you know that it's there. That's the Wildwood Lagoon. This is the existing town site treatment plant, or to be specific, that little thing right there is the existing town site treatment plant. And First Beach is this area right here. And here's the Westview treatment plant site. You're probably most familiar with that one. So about March last year, the city asked Associated Engineering to work up 2 possible themes. and eventually selected the natural integration theme, which was a theme that would integrate the facility into the natural environment and blend in as much as possible with the surroundings. And we'll show you what that has involved. But at that time, we gave quite a few sort of landscape views of things, and I think we have one or two in the slide deck that I'll show you shortly. We had a public open house on May the 10th, showed this approach, and Council passed the motion on the 17th of May to proceed with detailed design of the natural integration theme. You may recall that this is what it looked like. So what you'll notice on here is just barely is that on the roofs of 3 of these buildings, 2 buildings, and also across this area, which has been added subsequently, we have a green roof that will grow natural grassy vegetation, help things to soften the landscape and to blend in. Just so that you would know, around this area here is where the existing townsite wastewater treatment would be. So this is sort of how things would look after it was removed, and we could use some of that area for parking along First Beach.
Mr. Robinson, here has a, here.
Yeah, can you go back to the...
Certainly.
So I heard you say a few things. I heard you say green roofs. I can see a little bit of a green roof there. And then I heard you say that we're contemplating a roof on the first set of reactors in front.
That's strictly talking about.
So, yeah, I think we'll have images that will help you with this later, but when we showed, yeah, okay, you can see them actually here. You just don't see. So this area right here,
Right.
and this area right here,
Oh,
have a shed roof that slopes upwards, sort of facing the town site.
right.
That's a green roof. In this angle, it just doesn't, you don't get to see it. Here was the plan view that we used at that time. And I said was because it's slightly changed. There's a significant group of trees here and another significant group of trees here. The roadway doesn't go through them anymore. It actually comes around them down to this area. But otherwise, things were pretty much the way we had laid them out in May 2018.
Okay, and again, Chair, from the bottom of the new proposed road around the trees, we have a dedicated right-of-way on that dirt road, correct?
Yes.
Yeah, thanks.
That's currently where our influent line to the town, one of the influent lines to the town site comes from along that roadway.
Okay.
Where are those the green roofs right there we were talking about?
Thanks.
I'm not sure how much you want to know about the process, but I'll just go through the key unit processes that make up the overall system. Wastewater arrives, goes through screening, degridding. That removes a lot of material that can be problematic downstream. Gets into pumps, wraps around equipment, various things like that, and grit causes a lot of wear. So the earlier that that's dealt with in the process, the longer all the equipment lasts downstream. Then we have secondary treatment, which is an aerobic activated sludge system. Over 90% of the treatment systems around the world use one form of this or other, and so it's both it's a tried and true system, and also when it's done in a modern way is a very effective modern system as well. Secondary clarifier, ultraviolet disinfection prior to discharging through a new effluent system and diffuser that's about 60 meters deep, just off of First Beach, and about 1.5 times, or maybe closer to 2 times as long as that jetty, that sort of hockey stick shaped jetty. So it's quite far out now into Malaspina. We also have odor control, which we'll talk about a little bit, and then when it comes to the treatment of residual solids, we thicken to try to get 80 or 90% of the water out of them. They will be aerobically digested, which means with air, with oxygen, which is a process that does not cause odor. And they will be dewatered as they are now at Westview and then sent to beneficial reuse, hopefully one day on this side of the water and not on Vancouver. Odor control, effective odor control has been a key consideration in the design. Foul air from raw wastewater and odorous processes will be contained and treated with the best available odor technology. Solids produced in the treatment process will be aerobically digested prior to being dewatered and transported off-site. And oxygen, aerobic oxygenated processes will provide high-efficiency biological treatment of causing odors. So as
I just have a question. Are you
Yeah.
going to, at some point, talk a little bit more about what if you back up the slide, that
Sure.
first bullet, what are these best available technologies?
Sure. I don't have a slide prepared for that subject today. Let me think about that, and we'll see if we can address that for our time. Is that okay? Yeah.
Yeah.
Okay. So as I indicated when I started, we used a 3D software package to provide the renderings and the views and so on that were served the purpose and served that need a year ago. Now we've used a different package, and this is called Revit, and it's a package that allows detailed design of structural, mechanical, electrical, odor control, piping, all these things to be done in the same three-dimensional space. It's very useful because it enables all the different disciplines to see how their work fits in context with all the other disciplines. And what that means is that we don't have pipes that accidentally run into concrete columns. We don't have electrical cable tray that's using a certain space that the piping designer thought was available. And so it really lets us deal with a lot of three-dimensional conflicts that can show up later. These are often the quality issues that generate additional costs during construction, and we will have eliminated many of those, perhaps all of them. So we'll show you that today. We did a review of this design with operations staff on the 20th of November, that should say 2018. We did a 60% design review with the city staff in our offices on January 22nd and 3rd this year. And we did a 90% design review with the O&M staff here in this room this morning. And now you're also getting a chance to see it. So this is where we're switching to the 3D model. Right, go ahead. And I'm going to transition to Michal Simhan, who will walk you through the model and show you how the process has been put together in 3D space.
Okay, so let's just have a look at the overall site plan. So you will see, let's get my laser pointer here. We have three major buildings. This is the administration building in the back. We have a process building over here that houses most of the equipment. And then we have a bioreactor complex over here where the aerobic process happens, digestion happens, and there's a process gallery underneath over here. So, Brad, why don't we start where the wastewater comes in?
Okay.
Okay, so, of course, this is not, the model just shows the the grass to end here, but obviously it keeps going up towards the town site. But the wastewater comes in one common pipe over here. And then as you go through the wall, so wastewater enters a channel. Looks quite blue over here. Obviously, wouldn't necessarily be that blue. And then it separates into one of 3 channels. So, Brett, can you do an overview, like a
Yes.
bird's eye view? Yeah, awesome. So flow comes in and it separates. It either goes to the right over here, or to the left, or in an emergency through this emergency bypass over here. So under typical operation, it would go either to the left or to the right. So let's say we go through the left, through one of these gates. Here is a, what we would call like a trash bar screen. That would be used, it wouldn't be commonly used probably to remove things like large grease buildup if that were ever to take place and end up in the force main. But normally that would be in the up position. You wouldn't need to use it. And so flow would continue through and go through this screen over here. So this is what, this kind of screen is a band screen. So flow actually rotates as if on an elastic band. And with the screen wastewater goes through the screen, out here and around the screen, and then through these channels. We just hold there. Now the screening's material, so that's the solids that are captured in the screens. Brett, do you want to just back up a bit?
Sure.
A bit more? Yeah, okay. So in the screening unit, there's what's called a washer compactor. So it washes the screenings, takes out some of the water, and then it goes out through this chute through a screw conveyor. And if you just zoom out a bit, yeah, so there's actually 2 screw conveyors, one for each screen. And so the screenings would move all the way down here, each of those conveyors, and then it would drop to a bin that is on the floor below. So we'll get to that after, but that's what happens to the screenings. And then if you keep going through the flow of the wastewater, so you go through the channels. Okay, and then if you can, okay, so this is through a partial flume. So what this unit does is it measures the flow that's going through the treatment plant, so you know what's coming in. And then, Brett, if you could do a bird's eye view. Yeah, so at this point we've actually transitioned outside. So we were, for the screenings, we were inside the building. Now it's a bit of a change. There's if you look up, there's actually a canopy, and that is where the green roof is situated. There's a few access hatches at the top here, you see. And that is what, in some of these locations, you're actually able to bring over a crane and lift equipment outside, up and over, and replace it that way. And then if you keep going through the flow, so past the partial flume, this is the location where the degritting happens. So the grit is particulates, things like sand that accumulates and leads to a lot of wear and tear, pumps and other units downstream, so we want to get rid of that. So Brett, if you keep going through that. So the way this happens is we have this vortex system. There are mechanical paddles that move, and the grit is separated from the wastewater. Okay, let's go about that. Okay, now in the event, unlike the screenings where we had one unit that was in operation and another that's, so we have 2 screenings unit, but only one is required at one time. So if one broke down, you could use the other. For the grid system, we don't actually need that level of redundancy. So when the grid unit needs to be taken offline for whatever reason, there's actually a bypass channel just beside it. So that's over here. And so, oh, sure, yeah, sure. So you'll actually see here, all the channels appear to be open. In reality, we would actually have grading over top, so no one can fall in. But also it's to allow for containment of odors. And so you'll see connections like this pipe over here. It's actually connected to the cover, and it would draw foul air directly from there. So when you're standing in this space, you wouldn't be smelling anything.
Excuse me, through the chair, so those channels that are collecting the foul air from below grade and then running through some filters we're going to hear about?
Yes. Okay, so then let's go through the channels. Yep.
Actually, council, it's not grading that's on top of those things. These will be solid.
Yeah, checker plate covers.
So unperforated?
Unperforated.
Correct.
Yes.
Yeah.
Thus
So-
trapping the smell.
Yes,
Yeah,
yes.
and if you ever needed to look into the channel, you have to lift it up. You can't see.
You can't see
them.
through.
Yeah.
Okay.
So then what we have here is what we call a splitter box. So it splits the flow evenly into four. So you'll see 1, 2, 3, 4, and each of those streams is going to go into one of the bioreactor secondary clarifier components that we have. So if we go through one of them. Okay, so we go out this gate. Oh yeah, and then this is just an area, just to do some work here. And then eventually it would, so the pipes are, at this point, they would be underground buried, and then they would go to the to the bioreactor complex. So Brett, can we walk there the way we actually would walk?
Along the road? No.
No, other way. And then up above the secondary
Yeah.
clarifier. So in the meantime, sorry, just pause there. If you look to the left, turn it to the left. Yeah. So you see all these roll-up doors. Maybe zoom in a little bit. There are roll-up doors here. So if you recall before, I said that there was screenings that were collected from the screens. They're dropped to one of these bins. Which one is it, Jason?
The one that's on the left is the screenings, the one on the right is.
Okay, so they're dropped into this bin, and out of the grid system, those are dropped out into this bin. So those are collected, and then those need to be taken to a landfill. We can't use those beneficially. Similarly, if you turn just a little bit to the left, Brett. Yeah, so over here, it's not modeled yet, but a septic receiving unit would go in there, and so septic haulers would come in, park the truck over here, unload, and then leave the site. Okay, so let's keep walking towards the...
So, excuse me,
Yeah.
through the chair, the product that can't be beneficially used, that you just described, we said needs to be landfilled, so where will that end up here? So we would pick it up here.
Yes.
This is to Tour.
Yes.
It's converted. And then we would haul it where, and does it smell?
Those bins can have a cover on it so that they would be sealed units to remove from this location. And currently, we transfer that type of waste to Pigeon Lake in Coma or Courtney.
Where are we going to store it in the meantime?
It's stored here until it's ready to go. These are our, how many yard bins are they?
20 cubic yards.
20 cubic yards. So then we'll just swap out
So
another
they go
one.
right up.
Yes.
Yeah.
So you fill up here, cover, shipped right out to Pigeon Lake, and then a new one goes in, and when it's filled, really?
Yeah, and one of the benefits that you will enjoy with modern equipment is that the level of washing on the screens and on the grid is significantly better than you've got at any of your facilities right now. And what that means is that the level of organics that's being left is much lower, and that reduces the odor potential. It's not difficult to be around this equipment. Nevertheless, it's indoors, in covered bins, with the doors closed, where all that air is being pulled into the odor control system.
Through the chair. How much, how often are we going to have to truck that, do you think, for community?
Not on a very frequent basis.
No, I would suggest once, less than once every 2 weeks, but I'm not sure the last time we looked at that. The bins are quite large.
Yeah.
And the city would have the option of going with smaller bins if they wanted to do that more frequently.
Yeah, but that was through the chair, the follow-up question I wanted to have. Are we going to see a lot more trucking costs then with this system than we're used to? Because right now we have the biosolids that build up, and then we take them to the lower mainland, I think, or to the or peninsula, where they spread them in the forest there.
They go to Vancouver Island.
They go this way?
Solids do, yes.
So we got this sounds like we're going to have more trucking.
Currently, if we follow the process of today, we'll have more trucking because we'll collect just in the 3 processes that we currently have. We'll be trapping more trash, and we'll be collecting more biosolids. Okay, so yes, initially our trucking costs will go up. Ideally, we're looking for a stay-at-home answer for our biosolids. At this point, we don't have a way of dealing with that waste within our region unless we truck it away. So with biosolids, yeah, we're looking for stay-at-home options, but we're not there yet.
Yeah, but to carry on, but these particulates are not part of the biosolids, they're separate.
They are, yeah.
Yes.
Right, so now we got the biosolid issue. We don't have this particular separation now, do we? So
We have some trash that we collect that we bring to Pigeon Lake. Currently, it's stored at the transfer site, so our guys collect
our transfer site?
Yeah, so we collect bags of it. It goes into a bin that's located currently in the transfer site, and then when that's filled, it goes over to Pigeon Lake. So obviously, that run will happen more often. To what extent, we don't know just yet.
One more question. So what typically makes up the solids that are not going to contribute to, but like what would be in those
Like,
solids?
so in the screen solids, plastics, rags, anything that's flushed down the toilet.
These
Swifters.
grits? So these
Yeah,
grits?
Swifters.
Swifters, yeah, flushable wipes, any of that.
Okay.
That's what would be removed.
So if people come a lot better at not flushing these kinds of things,
Yes.
our waste would reduce.
The screenings amount, yes,
Okay.
yes, definitely, yeah. Any other questions so far? No? Okay, so if we keep walking down here, and so Brett, if you could just go on top of one of the walkways. So, yeah, let's just pause here. So this is a bioreactor combined with a secondary clarifier. So what happens is the aerobic treatment takes place in the rectangular portion, and then wastewater then goes into the circular portion where there's an actual separation process. And from here, all that's left between getting this now treated effluent out to the ocean is just UV disinfection, which I'll show you in a minute. So the way, Brett, can you do a bird's eye view?
Yep.
The way we've configured this is there's 4 identical suites. So there's 1, 2, and then 3, 4. Whenever you need to take one out of service, you would take down the entire system. So that means the secondary clarifier, the bioreactor, all of the pumping associated with it. And while you're doing work on whatever component required maintenance, the other units could be used. So you have full redundancy here. And so we can just, Brett, let's walk across the bridge here. So let's go across the way, and we'll just show what it looks like with, what the mechanism looks like without the wastewater in it. Yeah, so that's sort of what the components look like. Can you do more of a bird's eye so we can look at the aeration system? So these blue panels down here, diffused aeration. So you have an air header coming in, really small bubbles are produced, so fine bubble aeration, and that's what helps with the breakdown of the organics in the wastewater. And then it moves over to this secondary clarifier, where the clarification process, so the solids separate from the liquid. Okay, so Brett, can you go into the gallery through the stairs? Yeah, so this is now simulating what it would be like to walk down these stairs. So this is into the gallery. So in here you'll see there's essentially 3 pumps for each of those components, each of those units or suites. So we have a scum pump, a waste activated sludge pump, and a recycle pump. If you keep walking down, oh, let's turn the other way, sorry. Okay, so let's just stop here. This manway is what we would call a marine manway or marine access door. So whenever one of those tanks is taken offline, rather than having operators go down in ladders, we've actually provided a way of entering the tank safely through the gallery. And these stairs over here, they're not permanent stairs. You can move them around. And so we've shown them in a few places, but it's just one set of stairs that you move it to whichever location you need to. Here's some blowers that provide air for the aeration process. And let's keep walking down here. So entrance into this building, you have a roll-up door here. And so the way that equipment would be maintained, you'd bring the forklift in, lift up the pumps or whatever other equipment you need to, and take it out. There's also a manway over here. And then along the way, you'll see there's also quite a bit of, a lot of piping in here, ducting as well. Okay, now let's walk the other way.
Excuse me.
Yes.
Sure.
Yeah, I've got a question for you and a quick comment. The question is that the aeration tanks that are there depend on pumps pumping air through the liquids to do the treatment process, right? Is that,
Yes.
Is that is the amount of air required change depending on temperature? Because I've heard other people say that some treatment plants on hot days tend to emit odors and some don't, and I just wonder if temperature makes a difference in the process.
I mean, temperature wouldn't be the greatest factor that would affect it. Really, the equipment that we're selecting here is fine bubble aeration, and that piece of equipment is so efficient in transferring the bubbles to the wastewater. And the way that we would control that is making sure that there's sufficient oxygen in the water, that the transfer of oxygen is taking place. So we would be measuring that and controlling that, and you would be able to provide more air if required or less air if required.
And are there, and just on the same topic, is there backup systems in case the air pumping systems break down?
Yeah.
You are correct that biological systems operate faster in warmer temperatures. And you're also correct, though you may not have intended to be specific about it, but it's harder for a blower to compress and blow air when the air is warmer and less dense. So 2 things happen when the temperature warms up. The process picks up, it goes a little faster, probably only a degree or 2. Water isn't changing temperature like air temperature is on a hot day. But blowers have to work harder. We've taken both of those factors into account, So there will be more than ample oxygen for all days of the year. If a blower breaks down, then the wastewater would be which should almost never happen, by the way, and especially with the proactive maintenance program, that shouldn't be happening. If that were to happen, then the process of one tank is emptied into another tank, and the blower is repaired and worked on. So there's no situation where nothing's happening for more than 24 hours.
Okay. Just the last comment was, we've had some discussions about this, and I think we'd prefer to have personnel doors rather than manways.
Fair enough.
You're lucky our youth aren't here.
And just to add, there is a blower dedicated for each system. So like Tom mentioned, if one of the blowers were to go down, you just transfer all the wastewater to one of the other 4 components. Okay, so let's keep walking down. So following the secondary treatment process, and just before we send the treated effluent out into the receiving environment, go through UV disinfection system. And so, Brett, can we look the other way? Oh, at the bulbs, I mean,
At the bulbs,
or
yeah.
at the lamps.
For sure.
So flow comes in and then it goes up over here and then out here and then out the outfall, or out down here and then out the outfall. But just before we go there, let's just turn back to the lamps. So this is where the UV lamps reside, and this is where you take them in and out from. Okay. And so typically we have 2 of these units in operation, with a 3rd one on standby if we needed to do that. And then if you turn around 180 degrees, so this is just an access door out here. We did not provide roll-up doors here, that was just on the other side. So if any of the equipment on this side needs to be maintained, it has to be taken out the other direction. Can we go out this way?
Mm-hmm.
Yes, I can go out. Okay, so in addition to the secondary treatment process, we also have aerobic digestion over here. Can you go a bit closer? Yeah, and actually let's go to the empty one.
Mm-hmm.
So there's 2 units here. Geometrically, the rectangles are exact dimensions to the other 2, or to the other 4 rather. And that was done a bit purposely. If in the event that you needed to add that much more capacity, you could actually retrofit these spaces to add a 5th and a 6th space. So right now the solids are collected from the bioreactor, and then they're aerobically digested through, these are the aeration headers over here at the bottom. And then if we go back to the process building, I can go into the DAF room. So this is a dissolved air flotation system. We thicken the sludge over here before sending it to the centrifuge, which dewaters it. So let's keep walking over here.
So this is our biodegradable solid waste?
Yes.
Right.
Okay. So these are the centrifuge units. And so from here, you would get the material that is then ready to be used beneficially. So right now it's being dropped into a bin on the floor below, actually. Okay, let's turn around. And then can we just look at the electrical room?
I've got a question for you.
Yes.
The aerobic digestion of the solids, what are you looking, like, what is the purpose of breaking down the solids? I imagine biologically, so you're basically just breaking it down into simpler
Yeah, you want to
molecules or what?
stabilize the solids before you actually use them beneficially. And so there's numerous ways of doing it. We've elected to do it aerobically. And then, so doing that coupled with the thickening of it allows us to create a nice fine and dry material that can then be reused.
So it's kind of like chemical digestion of wood fiber or stainless fiber. What are you breaking down exactly in there? Is it mostly cellulose type fiber and other long fibers like that?
Well, it's not cellulose, it's not a pulp mill that we're...
No, but there's lots of paper in this.
There is lots of paper, so there's some of that for sure.
Yeah.
But it's organic waste. It's the bacteria that are produced in the treatment process. You need some to continue to operate your process, but probably 20% of what you're producing you can waste on a daily basis. And so you can think of it like a composting process. When you put fresh material in the compost and turn the pile after a period of time, the aerobic bacteria have degraded it, and you've got a more stable product that has beneficial properties for soil, that kind of thing. I'm not a soil scientist, but I think you can all understand what I'm talking about when I refer to it that way.
Okay, thank you.
Just through the chair. When you say aerobic, does that mean with air,
With
or
air,
does
yes.
it mean agitating? Or
No, it means with air.
Okay.
Yeah. Okay, so we're just going to go through the electrical building, or electrical room quickly over here. Okay, and then Brett, if we could go to the admin building. So right now we're not actually showing the driveway into the admin building, but the entrance would be through these doors. Okay, and then just on the right here, we have 2 workstations for the operators, and they're actually able to look down over the process. Okay. And then you enter a much larger space, sort of common area. There's a kitchen over here, and again with the view of the process. And then on the other side, a screen. So if ever a larger meeting needed to take place, this would be the place where that would happen. Okay. And then over here we have an accessible washroom just on the left-hand side. And if you keep going, there's a meeting room.
Go back to that little meeting. There's a view there at the window. Guess we could send the CAO there.
I'll sit wherever you are.
Okay, and so then here just on the right, we have a little laboratory space to do some sample preparation. And again, there's a view over of the process. So we don't expect a lot of lab work to take place here. Most of your samples would be sent out to a lab. Keep going. And so then now we're entering the change room area. So we've actually designated a clean side and a dirty side. And so if we enter the clean side, so this is where operators would come in first thing in the morning. They have a space, they have cubbies and separated or combined washrooms, showers, but separated stalls. Can we just go into one of them, Brett?
This is where
It's not that real.
Okay, great. And then this would be, once you have all your clothes on, you would. Okay, so you would exit over here, and then you could exit out, take the door out. Yeah. And walk out towards your space, which is actually on the other side. Yeah, walk around. So we would actually wrap around the grading over here. And then you're back to the front of your process. Okay, so that's sort of a walkthrough of the model where we're at. Are there any questions on that? Yes?
Yeah, through the chair, it certainly is easy to see how our costs have escalated by your wonderful presentation here today. Tor, have you got the white jacket and coveralls ready? I've got a couple of questions in terms of future. I know we've had these questions answered before, but in terms of longevity, lifespan of the facility, and population down the road that it can service.
Yeah. So what were the projected flows? When did that go? When did that expand?
150?
Yeah. So very comfortably on the growth projections that you have, including Wildwood and also bringing in the flows from Plowman, no problem until 2050. It would take something pretty dramatic in terms of a population bump to need to bring a fifth or sixth module online. You know, it looked a little while ago, for a month back, that you might have one of those bumps, but that's the kind of thing I'm talking about.
In terms of equipment longevity, for things like pumps, we would expect anywhere between 15 to 20 years. Those are maintained well. The concrete could last upwards of 50 years easily. 75? Yeah.
So by changing out pumps and when necessary and that kind of thing, we could get up to 70, 75 years if we have to stretch this out, correct?
Yeah.
Thank you.
Yeah, so two questions. I'm going to go back to one of the first ones that Councillor Palm talked about. So what is the maximum population that we're guesstimating this could handle? So right now in the city we're about, I think, was it 13,500 or 14,500? And then Cohommon's about 900. So let's just say if we were 15, let's say we were 16,000, give or take 1,000. What would this be able to grow to as is?
So we do our best to anticipate the questions that we're going to get. I'll get you that one, maybe before the end of the day, but I don't have that for you offhand. But I think you would pass 20,000 here before you're breaking a sweat. But let's confirm that number for you if you don't
I'd
mind.
like to know that. Secondly, those two green panels there that are, as you can really handle solar panels, maybe. I don't know if they go, I don't think they're heading the right way. But what is their purpose, these things? Because they're wide open. Why do we have them there? What's the purpose of that?
So they're not wide open. We're waiting for an architect to provide the skin on the back sides of that.
Oh, okay.
They will provide a lot of natural light down into the gallery below. But the other purpose and the reason why they're inclined, they're green roofs that are inclined in that direction, is that from the town site view, looking down the facility, it really breaks it up, makes it look a lot less industrial, and greens the facility and blends it in. That was the purpose. And that's exactly how we rendered that a year ago, and you would have all seen that in the rendering.
Yeah, no, I did. But I guess so. the reason for my question, are they just put in there to add greenery, or do they have a purpose? And if they did have a purpose, and we just laid them flat, right, then you wouldn't see it, you'd see over top of it. You know, you would...
Through the chair, I think they're blocking the view of the reactors from above slightly.
Oh, okay.
Yeah, they're intended to be a bit of a visual
Deflection.
screen.
You don't see like they're sloped up, so from up above, you're looking at those, not at the reactors.
Oh, yeah. Okay.
So the aerator for the solids, if we in the future had so much population growth that we decided to convert one of those or what have you, then where would the aerating for the solids take place?
Sure, excellent question. The answer to that is that you'd need to build new.
Okay.
So you'd build new digesters at some other port on the site. What we're doing right now is we're keeping the footprint as compact as we can by bringing those 6 modules into a common wall footprint.
Okay, so they're located close to the other ones so they can be plumbed and whatever easily.
Yep.
The solid aeration would then have to be built somewhere else and that
Right.
would, okay.
But there is this, the site is large enough that there is space to build more.
But not needed
But
at
right
this
now, we were trying to be as compact as possible with the footprint that we were using.
Yeah, so I was under the impression the whole idea was that if we wanted to add 2 more, or 1 more, 2 more, they just butted up and we carried on.
Yeah, it sounds straightforward and it seems to make sense. Almost always when you try and do that, 20 or 30 or 40 or 50 years later, you'll find that it's very challenging to connect a new structure to an old structure. Codes are changing, foundation requirements are changing. So we may be able to put it right next to it, but in reality you don't tie it into the same structure typically. That can be problematic later on.
Perhaps you can go to our plan view and just show where the expansion would happen if we looked at it. So I don't know if you have that.
What about the civil plan?
And by the way, cool software.
I love Revit.
You have it?
I don't use it.
So through the chair, just a question on cost, because I know the last time you were here, you said it's going to be a lot more than the 30 million we had originally proposed. Are we any closer to having a price tag on the overall structure?
So we did do a cost estimate at a sort of a Class B, C level in support of the decision that Council made last May. And then subsequent to that, we prepared a grant application for the Invest in Canada infrastructure program. And there were a few elements that were added into that strategically, for the city's benefit. And so the number that went into that program was around 80 million. At this point, we, in terms of the treatment plant, we think we're on track. And if at such time as we're going to tender, we would update that with a Class A cost estimate. And if that's in a reasonable time frame, I think we'll be fine.
Thank you.
There's a lot of work out there right now. It's not the best time for a competitive landscape, but it is what it is.
That's true. Thank you very much.
Yeah, so back to what the Council Brown has suggested. So, you're saying 80 million with some strategic additions we did for the city. A, what are those strategic additions? And B, we still had a pretty stiff contingency attached to this, right? So those 2 questions.
Yeah, I like the word stiff. That's good. Well, you have some sewer issues up at Artevant. Although they're not connected in any specific way with this, the city chose to maybe look at those, doing those at the same time. And that's basically capacity issues and probably groundwater issues up there. That's one example. We also...
Was that taking care of any of our I&I?
It deals with those excessive flows in our wet season around that Cranberry Lake area that where we've experienced some issues in the past.
Okay,
Not this year,
yeah,
thankfully, but in previous years we have.
okay, that's strategic, yeah.
We also included the cost for decommissioning of your 3 existing facilities,
Oh, yeah.
which we had in the original build, right? But it's
That's gonna be good.
it's got to be part
Gotta
of the
be,
project.
yeah. And what was my last question?
Stiff.
Yeah, how much is in the stiff account? What's our contingency, what percentage?
percent was it?
15?
We
15% was it, or?
No, it was 30.
had 30% in last May's estimate, which was about 15 million.
Yeah.
So
So give or take 15 million.
if you were going to tender now, we'd do a Class A cost estimate, and the contingency on that would be much lower, but we have a lot more information to work with.
Yeah, that's right.
Yeah.
Thank you.
And one of the benefits of the modeling software is that, the quantity takeoffs that you can do are
Better, it's more accurate.
And actually, if I might add, this morning when we were going through the 3D, we were following the air ducting, and in one location, you wouldn't have been able to see it in plan view, but the bend happened in the doorway, so you wouldn't be able to have full access in and out of the door. So the bend will happen just past the doorway now, so you wouldn't have seen it in your conventional
Drawings.
planning software.
Yeah, it would have been an additional change at higher price.
We would have brought it in at construction time. The contractor would have brought it to our attention and said, "This isn't going to work." And we said, "Okay, so remedy the situation," and they would come along with a bill that was probably exorbitant in relation to if they had to write it the first time.
So that's one of the benefits in this design approach, is that construction change orders are lower.
Yeah.
You're just not identifying, there's just not as many issues that the contractor comes across. There's a bit of a belief that contractors, you don't want to be able to write a lot of change orders, but when you meet them and talk to them, they actually also appreciate a project that's been well designed so that they can just get on with it. So it actually helps them to bid a job competitively and know exactly how they're going to go about building it.
Councilor Paul?
Yeah, thank you, Mr. Chair. With an ever watchful eye on the cost figure that comes back from tender, have you ever implemented a plant like this with the amount of green roofs and living walls and everything that we have attached to this, along with, I believe that you had said previously, our filtration that we're putting in above and beyond the call of duty? As to cost, have you ever seen that combination go in anywhere else?
Well, I don't know if you intended to hand me a great segue into the next part of the presentation, but I might use it that way. 2 things. Mark Porter can speak to other projects where we've built green roofs, because I think that's part of the question that you're asking, so thank you for that. And also, when it comes to going above and beyond, I would say this plant neither goes above nor beyond. It's going to meet the regulations that are in place now. It's provided a design that can be accommodated for future regulations, although that's a bit of a guesswork. We like to call that future proofing, but and what might those regulations be one day? Well, you saw in the outline that we want to talk about plastics. So there is no regulation for plastics right now, and we'll give you that presentation and show you how that relates to it. But just in terms of coming back to your overall question on costs, this meets your needs. This meets your needs going forward. This meets your population needs. But we've tried to think in terms of expandability or adaptability. One of the great things about square tanks and square processes is that if a technology were to come along in 30, 40, 50 years that we don't know anything about now that does a better job with these things, this is kind of the ideal footprint to be able to reconfigure your process. You've got the gallery, you've got those square tanks. This is a modern design. This is what you want.
Thank you for that, appreciate it.
Councilor
You want me to comment on the green roof?
No, I want you, I would like to tell council that it's 3:05, that this is the time that we said that we would transition to the next part of the presentation. But nevertheless, we're here at your...
Could you just talk on the coal filter? Because you said you were going to talk more about the aroma later when the young lady was making her presentation.
Sure.
You said we'll be talking about that later. Now is that in part 2? Because we did discuss taking that insurance plan, which was buying that system.
Yeah.
You said we didn't need it, but we said we wanted it.
Yeah, maybe Jason can give us some thoughts on that. Jason, why don't you come up and then we can transition into
And
your
before we move
plan.
on,
Mhm.
I would like someone to help me understand a little bit more about how the solid waste aeration, how solid waste is moved in solid form into the aeration and out and all of that stuff. It didn't make a lot of sense to me because it was kind of glossed past. I don't really know how that happens. And maybe I don't need to know, but
Should we
I'd
do that
like
in
to.
this context, or
I'm not sure. It's your presentation. We talked about it here. I didn't understand it.
Mm.
I would like to, that's all.
Could I suggest that, like, I'm not going anywhere afterwards, that maybe you and I can talk and I can take you through that process? Sure. I'd be happy to
That'd
do
be
that.
wonderful.
Jason will talk about the odor control system that is going to be a part of this design.
Council, so the odor is in general a very complex topic because there are many odorous compounds that are made up in wastewater systems. And the system that we've selected is a 3-stage system that is using organic methods for breakdown of the organic odorous components. So we start off with a biotrickling filter, followed by a biofilter, followed by an activated carbon filter. And what this does is the biotrickling filter removes the water-soluble odorous compounds, while the biofilter handles the non-water soluble odorous compounds. Then on the back end, prior to discharge, an activated carbon filter is used to remove any of the additional, whatever residual odorous compounds are left over.
You didn't see that in the process walkthrough, and that's because it's a proprietary system. Typically, we don't get involved in the designing the little bits, but it will be right here. At a certain point in the design, you would have seen some piping and some of that material that was above ground, but we're moving more of that now below ground, so that's why when you panned over the system, you just didn't see it.
Is odor captured off the larger open vats as well, or is it just
Odor is captured
before it gets-
everywhere it gets generated, or
Okay.
everywhere it has the potential to be generated.
So
And one of
how-
the things that we've been working hard to assure council of
Yeah.
for 2 years, and we'll keep going.
Yeah,
is
sorry
that-
for my newness.
No. Is
So
that,
the big open vats, how would the odor get captured from
Before
to
it
go?
gets there.
so aerobic
Okay.
processes
Yeah,
that involve oxygen do not produce an odor that's in any way noticeable or offensive, even at the fence line of the facility.
okay.
That's the beauty of aerobic processes. Pay for them by providing air and diffuser systems and so on. But that's the beauty of aerobic systems.
So where we're capturing air is in
Yeah,
in
under
the
the
process
walkways.
building, and that's where that's why it's a contained building. The sections are contained with air being extracted from those areas and filtered through, the 3-step process, and ultimately through a charcoal filter before it enters the atmosphere. So all that is contained essentially within that building, but scrubbed before it's released into the environment.
This is the most odorous area of the plant. Can you just get past the grid unit there, because it sort of distracts things. I just thought it would be worthwhile to show this and remind you that the raw wastewater coming in those channels, all these channels are covered and sealed, but what you didn't notice necessarily the first time around is what I'm going to show you now. You see this pipe here? If you zoom in on the bottom, it just sort of ends, but it doesn't actually end. It will connect to the cover, and that's an air duct that is vacuuming air out of that channel. There's another, and they're all over the place, and indeed on the screens themselves, we have connections that are taking air right out of the screens. So all the leakage, if you want to call it that, of air in this system is from the room into the channels, into the screens, in areas where it's being vacuumed and taken out. So just sort of pan up into the ceiling areas. It gets pretty ugly when you get up top, because all of this stuff up top is air coming from different parts of the process. And basically everything is moving east. And by the time you get into the bin areas for the biosolids, the duct is, I think, 30 inches diameter, and that goes down and underground and over to the Odour system. So there's a lot of effort here in some fairly large diameter air moving equipment to actively pull that air off these parts of the plant and treat it in the odor control system.
Excuse me, through the chair. So is that odor control system part of that charcoal thing, or the charcoal filter is in addition to that?
Charcoal system is in addition to the biotreatment biofilter system.
Right.
So
And
it's a
that is
three-stage
why
system.
we were told you really don't need it, but we're doing it anyway.
Yeah.
So Chair, can I ask that we move on so that we get the entire presentation in before 5 o'clock? And, I mean, I don't mind some questions, but I think we beat the odor issue to death, and everybody gets it, and I'd like to see the entire presentation, if we could. Thanks.
Are you going somewhere?
Not necessarily, but they
They all
are. They have
like-
to go at 5.
All of
Well, Tom said he would stay if he
I don't
had
get my
to.
questions.
Plastics is a big topic for you, and you know, so many other people right now are looking at the problem of plastics in the ocean with a sense of sort of hopelessness and helplessness and concern. What we've prepared for you is a bit of a primer on the topic. I've broadened it to plastics because we're all aware that, you know, the problem is at every scale. So Jason's going to give a little bit of a presentation once through, and then we can talk about, to the degree that you're interested, how this relates to the project that we're doing here. Okay? But this is just intended to help you and support in your discussion.
Thanks, Tom. So as Tom kindly introduced me, I've been working on this project for about 2 years with Tom, and I'm going to talk about a little bit of a primer on the background of plastics and microplastics, particularly in the marine environment and how they affect and so forth. So when we're looking back and we're thinking about plastics and microplastic pollution, what we're typically used to seeing is the discussion about large plastics within our oceans. Large plastics coming from various sources that are persistent in the environment and stay forever and have been shown to be harmful to animals. So we're quite familiar with this. There's a large number of articles that date back to the mid-90s when the first discovery of the Great Pacific Garbage Patch was discovered in '97. And we see a lot of articles that do talk about this and how they affect animals because an estimated 8 million tons of waste plastics are added to the oceans every year. Now, this is an example of some photos taken of waste plastics that have been floating at the surface in marine environments. And their effects to wildlife have been proven detrimental, where issues like entanglement and ingestion have been shown to be occurring, leading to mortality of these marine animals. Now, how these work is the entanglement will either increase the likelihood of the animals drowning or increase rates of predation, or ingestions being that they do suffocate or encounter blockages which lead to mortality. So, common topic that we all know and are pretty familiar with, but one that is emerging that there has not been a lot of discussion, well, it's emerging discussions, the discussion of microplastics. Now, microplastics are smaller plastic particles that you're probably not used to seeing in the environment because they are quite small, and they come in two flavors, one being primary and secondary. Primary microplastics are things like microbeads, where they're made to be small and are added to consumer products or other products that are introduced in the environment in an ad hoc fashion. While secondary are is defined as microplastics that are derived from breakdown of larger plastics in the environment. So things like a water bottle left on a beach over time breaks down into smaller particles. And these are making it into the oceans, but right now we're quite unsure, well, as a whole, the effects are emerging. So this will be a discussion about these type of effects. So what are microplastics? So the general broad definition is a microplastic is a plastic particle that is smaller than 5 millimeters. That's a very broad definition. And lacks a clear scientific consensus because different shapes and sizes of microplastics are present in the environment, and how their effects for each size, color, shape, material is different to each. Another issue is that there's no standardized method to quantify or count the microplastics. And current best methods have a limit of size detection from 20 to 100 microns for a grain of salt. So because of this, it's kind of hard to compare studies where they have different methods for studying microplastics. So where do microplastics come from? They come from a variety of sources, all man-made. They come in a variety of flavors, colors, sizes, materials, and some examples of areas in which these microplastics do come from are fish nets or fabrics. These result in microplastics that come in the shape of a fiber. Industrial materials would be like the industrial feedstock for plastics. They come in pellets, or also called nurdles. So they would be B-type formations of plastics. Another could be fragments, which are, for example, made by car tires. So when your tires break down, they produce particles or fragments, and those would be defined as microplastics. Another would be a film, which would be derived from bags or cling wrap, items like that, or microbeads, which have been added to a lot of personal care products like toothpaste or facial scrubs and whatnot. So some images of the examples of microplastics. One a lot of people don't consider is actually cigarette butts. They're made out of a plastic called cellulose acetate, which will break down in the environment and create microplastics. And here are some microscopic images of some typical microplastics. Granules or pellets, rigid fragments, films, and fishing lines, which would be a fiber. So here's a little graphic. It's very complex that kind of show well, we can distribute this after. It's kind of hard to read, but it's a graphical illustration of where microplastics are originating and how they get into our marine environment. And as you can see, it's really complex. There's a huge variety of sources and a huge amount of ways that can make it into the environment. Some examples would be marine vessels dumping their waste overboard, or industrial processes where they're spraying abrasives, or runoff from the environment, say your roadways, where litter is accumulating. Others would be household applications where you're using personal care products, or printing, toners would be another good example of microplastics. Or potentially even industrial or agricultural applications where you would use a plastic mulch, for example, that could break down into film and make it into the environment. So hugely complicated, variety of sources, hard to track down, hard to isolate. Now, what are the effects of these microplastics? That's, I think, what most people are really concerned about. Sure, they're in the environment, but what are they actually doing? Here are some things that we know. Microplastics have been witnessed to be eaten by small organisms, small trophic organisms like plankton or other small organisms. And that has been shown to actually bioaccumulate and biomagnify in the food chain. So we've been detecting microplastics all the way up in the food chain from animals that do eat marine life, small trophic organisms being eaten by fish and whatnot, moving up the food chain. It's been shown that certain types of microplastics can actually act as hormone disruptors, so potentially disrupting the life cycle of certain animals, and even as migrating up the food chain. Microplastics can also absorb pollutants from the environment because of their hydrophobic nature. Hydrophobic pollutants will adhere to the microplastics themselves, and some of these examples would be PCBs or DDTs, other well-known kind of organic persistent pollutants that just stay in the environment. And once adhered to the microplastic and uptaken by an animal, that can also bioaccumulate in the food chain at a much faster rate. But overall, the global effects of what these microplastics are doing are not well known, because what we've been studying has really been at a species level, and it's been really hard to kind of accumulate the body of knowledge to understand what the global effects are. So, even though we might not understand what the global effects are, we can mitigate microplastics because it is solely man-made or human-made in the environment. So we can take steps in which we can mitigate microplastics. So, some methods that work off from easiest to hardest. Well, the first being consumer education, where we could adopt best practice, reduce plastic usage, or minimize plastic litter. So adoption of best practices could be, instead of using plastic bags at the grocery store, use reusable bags, which would eliminate not just potential plastic litter from end users, but also the supply chain in which plastics are produced and could be lost in transit into the environment, producing secondary microplastics. That also ties into reduction of plastic usage, which reduces plastics in the life cycle, and also minimization of plastic litter. So tossing plastics into the environment, littering, is a huge source of microplastic pollution. The second would be legislation, where we do, say, enact legislation where we ban single-use plastics or legislate against the use of specific plastic products for single uses. And the last would be end-of-pipe treatment, which is very difficult given that there are a variety of sources of microplastic pollution. Some of them not so easy to treat prior to it making it to the environment. So consumer education, another potential would be to reduce the use of synthetic fabrics and products with microplastics, or another potential would be to increase recycle programs or reduce the use of plastic waste, and also community cleanup programs where we're going around cleaning up our beaches, tracking down plastics in the environment, and trying to clean them up prior to them breaking down from larger plastics into microplastics. Legislation. So actually, since January 1st, 2018, Canada has actually put in a federal legislation that has banned microbeads in personal care products, and is coming into full effect this July 1st, 2019. And other countries that have followed in this ban have included the United States, UK, France, Italy, India, and some other countries. So globally, we are moving towards banning microplastics and their usage in personal care products. Another piece of legislation that has been passed as a private member's bill in our federal parliament is the bill M151, introduced by Gord Johns. He's the MP of Courtenay, Alberni, that has introduced to a second reading a national strategy to combat plastic pollution. This was agreed unanimously by vote on December 5th. And so right now, the federal government is actually looking at ways to implement a national policy or strategy to minimize plastic pollution into the environment. And then, again, the discussion of removal of microplastics. Not every potential microplastic migration route can be mitigated or controlled. So one good example could be discharge from your dryers. If it's not captured in your lid trap, there are potential microplastics that do make it out into the atmosphere from your dryer discharge. Another could be stormwater, where microplastics or plastics could be carried off as stormwater runoff and make it into the marine environment. But these stormwater outfalls are typically not treated prior to discharge, and would be a potential avenue. And there's also the discussion of wastewater and the effects of microplastics originating in household sanitary usage and making it into the wastewater treatment plant. From a quantitative perspective, removal performances in a wastewater treatment plant are not well known. There have been studies done that have ranged from 20% to 99% removal. However, because there is not a clear definition of microplastics and a standardized method for measurement, it's been difficult to actually compare the two studies or the magnitude of studies to actually understand how different treatment plants function and how they remove microplastics. So it becomes very difficult. But however, from a qualitative perspective, traditional processes will remove a certain amount of microplastics just through gravity separation or a screening process. However, the magnitude is not easily determinable at this point. So, in conclusion, microplastics are a global concern. We're seeing that in the global consciousness. Microplastics are making it into the food chain. We have witnessed this through studies, but the global effects need further studies. However, prior to actually understanding the global effects, there probably are potentials that they are negative. The risk is. Therefore, the potential risk of microplastics is making it on the radar of legislators, and potential legislation is coming in the future. However, as consumers, I think we are in the best position to affect change just by changing our practices, because plastics are a pretty easily identifiable source, and we can change our behavior to at least mitigate potential effects. Any questions? Yes.
Thanks for that, Jason. So I know there's the screening degrading process at the beginning of the treatment. Does that capture some of the?
Yes, so the screening process will, for the most part, capture larger plastics that could make it into the environment to break down into secondary microplastics.
But it was mentioned in the degrading part of it that separates sand out of from getting into the system, which sand, I mean the size of sand grains are similar to microplastics.
So the way the degrading system works, it works off it's a gravity-based separation method. So it's using density difference. So it will separate things that are heavier.
So not the plastic.
Well, there are plastics that are heavier than water, so we'll remove those. So things like PVC would be an example of plastics that are heavier than water that would separate out.
So some of them will float up and then they won't get captured in that process.
Yeah. But it could be that in the screening process, those would get removed because it's all floating through the same screen.
Okay.
And then there is also the scum skimming operation in the secondary clarifier. As that flows to the surface during clarification, that will skim off the top. So remove that from the process. And then there is also the gravity separation in the secondary clarifier that can remove other heavier microplastics.
So do we think that this whole treatment process is going to reduce the amount of microplastics entering the environment, whether it's the marine environment or the biosolids from what we currently are doing?
From a qualitative perspective, if you're comparing your treatment process, say Wildwood, it's a lagoon, because it has a long hydraulic retention time. Heavier microplastics or heavier plastics that sink will be removed relatively easily. However, because there's no screening upstream, things that will float will have difficulty to be removed. When you're looking at townsite just pretty much discharges anything, so the removal from that process is probably zero. And then Westview, because it has a two-tier system, there is potential for microplastics to make it into the environment. How much is kind of difficult to say. But from a qualitative perspective, it will do better than some of your processes at worst.
And will we be testing our biosolids for microplastic contamination before sending them out?
Well, that is a potential in the future because there could be legislation coming down for that. However, there is no standardized testing procedure to do that. However,
scoop it and send it to the lab.
So I've actually worked with researchers that were developing methods to identify microplastics. The trouble is they come in all shapes and sizes, all colors. They come in clear. They come in different densities. And to separate them from what is actually organic, what is brown versus a brown microplastic, and to look at it under a microscope and how to tell, that's very difficult. Now there's other more advanced methods to do it. However, there still needs to be more study and standardization. So when I was working with researchers, they were working in partnership with the Vancouver Aquarium, and they were using a very simplified method where they're using a separation with oil and a digestion procedure and then counting it under a microscope. And to scale that up to a full-on quantitative standard would be very difficult because staring under a microscope trying to count everything has its limits.
So what you're saying at this point is that it's the methods, the analytical methods aren't really available to accurately predict, but the process that AE is designing will remove, like how much plastic will be removed.
That's hard to say. Qualitatively, it'll do some removal, and in the future, if there needs to be some modification to enhance that removal to meet regulatory requirements, there is an allowance.
Thank you.
Speak to that. We can't measure what's coming in. We can't measure what's going out. That's not a problem that's going to be solved by people in this room. This is a global issue right now. There's no standardized procedure for measuring either what's coming in or what's going out, or what's going out in the biosolids. You know, what we can say is that you know, the system is better than what you've got now. You've got a patchwork. If the membrane were, you know, if Westview was a full-on membrane plant that was treating everything, probably capturing more. But, you know, in its condition, probably not very much. So this system will be better than what you've got, and that's just about all we can say, unfortunately.
Thank you.
I think what I hear you both saying is that this plant that we're talking about is going to be better than our current treatment as far as eliminating microplastics from the environment.
Right.
Yeah. The other thing I hear you saying is that council's looking for a way to deal with plastics in the environment, looking at eliminating it at source. Plastic bag use or plastic use in general is probably the more effective way to go around it.
Thank you.
Thank you.
Very good.
Thanks, Jason.
Okay, so Mark Porter's going to do a little talk on climate change, and specifically one of the things that I've asked Mark to do is talk a little bit about sort of the scope of the practice that he's been involved with, but also bring this from a global and a Canadian perspective down to the level of a local government in a coastal community such as you are in BC.
Tom. Yeah, so I'm going to start off with a little bit of science, and I'm a structural engineer who's been immersed in this stuff for a few years, but I've learned a lot from a very good colleague of mine, a climate scientist. Just to kind of set some background and then move into kind of, hopefully just kind of talk about what's happened, what's happening, we think, and then how that's been kind of looked at globally, nationally, locally, and so yeah, I'll whip through it, but if there's questions, please don't hesitate to stop and ask along the way. So yeah, just talk a little bit about how the climate has changed from observations, and then a little bit about the projections going forward, and how we can get that and downscale it to local, and then what that means in terms of at a city level in terms of impacts on infrastructure, and then talk a little bit about adaptation and mitigation and what other communities are doing and have been doing over the last few years, and and questions. So climate's changed. This may not work because it was a little crap.
Come back.
So this is so this is a NASA video which basically goes from the early 1800s through to 1918, I think. So it's 2018. Sorry. Just visualizing what's happened with recorded temperatures annually. So it's looking at how the Earth has warmed, and you'll see that the red gets progressively more and more and more. And so there's no doubt that there is change.
There's a whole meeting of doing 2018 to order. I just found out.
Let's go back to the presentation if you want to see lots of YouTube videos.
I think you would click it.
Right, there we go. So kind of coming back, so that was from NASA. This is looking at the latest report that Environment Canada has done. This just came out a month or so ago. at the national level, and this is looking at data trends from 1950, 1948 through to the latest records that we have, and this is looking at temperature, and the red arrows are kind of where temperature has increased, and the blue arrows are where temperature has decreased. And so, you know, as always, there's variation depending on the microclimate, depending on where we are in the country, but the message quite clearly for me is that the temperature is going up right across the board. And similarly, when we look at the same thing with precipitation, you know, the latest data is a little bit older, but the same thing is true. What we're seeing is that the percentage change, so the higher the darker the green, the higher the percentage change in terms of more precipitation, and where it's browner, the drier it is. And so what we're seeing there, if you look kind of on the west coast there, it's actually getting dry. But I'll come back to that in a little bit, because what we're seeing is an increase in extreme events and extreme events of precipitation. And so then what we've done is we've done a little bit of work just looking at some of the trends and kind of putting that into an infographic, and I've just clipped that for today to kind of focus in even more locally to here in BC. And so this is again still observed changes, and what we're seeing is actually there's change in precipitation, change in heat degree days, change in snowpack, and you'll observe some of these changes as well. And so this is all historical data. And I think the other big message is that what we've seen in terms of insurance and in terms of impact to cities and government, municipal level, provincial level, federal level, is insured losses. And I apologise, but you'll have a copy of the presentation afterwards. But that list on the right there is just the last 2 years, all of the events over $5 billion in insurance, 25 million. And so obviously that includes Fort McMurray, it includes some of the really big ones in the last few years, and the trend line is pretty clear that these extreme events are happening and they're causing more and more insurance issues for us as a society. So that's happening. And so what's and then just to kind of bring it even more locally, if you like, and I just did a little bit of research, and you'll have seen and you'll have felt in this community, you know, power outages due to extreme events, wind, you know, even kind of just this last weekend there were warnings, but this was in January, wind warning issue. So what we can see is those extremes of weather increasing in frequency. So and so what's been happening, and you're aware, is that we've been trying to match what's been happening with the climate change projections. And so at the global scale, this has been done all around the world. There's these big, massive computer machines that have been programming by numbers of scientists, taking what's been happening in history, modeling that with all of the events that happen naturally, volcanoes, forest fires, all of that stuff. They take all of that into account, huge computers, and they model it at quite a coarse scale, and then test it against what's happening with history to get the projections going forward. And actually they spend more time matching that to what's gone on in history to make sure that they're projecting it correctly in the future. So that's where the projections come from, and then what happens then, these are a fairly coarse scale, and so then we'll do some downscaling towards the country level, and then here at UVic and a few other places in Canada, they'll downscale it to kind of a broader area, and there's an area on a local site that's kind of unique to Powell River. And then what we've been actually trying to do is downscale that to a meaningful application at the project level. So what does it mean when we're building something for 75 years, and it's going to last for 75 years? How do we cope with that when we're building something that's going to last for that long? And then, so just to kind of bring that home, and this is a graphic that is an infographic, but it shows that, you know, we as a society are at a point where we have to start making some decisions, both in terms of changing our behaviour, but in mitigation, but also in adaptation to. We can't just do one all the other necessary. And this is temperature. And here, kind of just looking at that at a national scale, again, this is temperature. So we are actually in, if I can use this point, sorry. We're kind of about here. And what's happening here, these two pathways, is if we manage to reduce the amount of carbon that we're emitting, and severely reduce it, then we can follow the blue line. That's working. However, all of the modelling at the moment suggests that we're tracking on the red line. So we're kind of going on that higher path. And so when we're looking at adaptive measures, when we look at the scenario in kind of 70, 75 years, we are tending towards looking at what's going to be happening on that higher line rather than the lower line, assuming that we're not going to make it. Hopefully we do. And so those graphs. So this is precipitation. So the numbers there at the bottom, RCP 8.5, 2.6, that's basically modeling what society would do if we continue to emit GHGs at the same rate. 8.5 is kind of at the same rate as we are today, and 2.5 is if we start to reduce. Don't ask me to tell you exactly what RCP means. It's something pathway.
Representative and concentrated.
Yeah. And so what I did here was actually go on. So there's a link to the University of Victoria's Pacific Climate Impacts Consortium. They have a really good website that you can very quickly get some general trends for what's happening in the local environment. So just for your information, I went in and I looked at what was, what they were saying for Powell River in terms of impacts for Powell River. And so decrease in snowpack, more high-intensity precipitation, increase in hot and dry conditions, increase in temperature of the season. Now, what I will say is that some of these things could be viewed as a benefit. You might get more growing days. You might get some other things that are viewed as a benefit. And so part of this is not just looking, when we're talking adaptation, it's not just kind of the things that we need to do to protect ourselves, but also maybe look at ways in which we need to adapt to change and take advantage of that change. And then kind of looking out to 2050, and we can also look out to 2080. What does that mean? So mean temperature is going to go up, precipitation. So here's interesting. So the median will go down, but we'll get more intense rainstorms. Snowpack will change, which will probably have effect on the freshet and flood levels in the streams and things like that, water levels in the dams. Those kind of things. Growing degree days will go up, heating degree days will go down. What that means is that you're going to need less heating in the winter or cooling in the summer. And so your energy demand on the houses will change because they're going to need cooling in the summer. So how do we work with that across 3 days? And then so, well, what does that mean for the city? What does that mean for us? We can't stop it, we may be able to slow it, and so we have to adapt, and I would suggest that we have to mitigate, continue to mitigate. So what I thought we'd do now is just look at some of the impacts, what that means in reality to infrastructure, and I've tried to stay relatively local in terms of impacts that you'll have seen on the infrastructure, just so that it kind of brings it home. So kind of sea level rise is an obvious one. So it's predicted to rise by, it will take around a meter plus storm surge plus various effects. And so this is taken fairly close to here. And this was from a Twitter feed not so long ago. Representative impacts, storm and sanitary storm backup, flooding on the road because of storm surge in the king tide. And so not that king tide is new, but the point here is that the high tides, the storm surge, those kind of wind events are going to perhaps be more frequent, and so this kind of thing can happen more often. Summer extreme heat, wildfire, I think is a huge one. We've seen it. You can probably tell from my accent, I'm not native Canadian. We moved here 12 years ago, and in the time that I've been here, my wife and I have observed that the incidences of fire have increased amazingly. something that we just observed just as a family is that, you know, we're now considering where we go during our summer breaks because of the risk of wildfire. And I think on the West Coast, that's we're pretty vulnerable to that. And again, this is one that was just very close to here. This was actually done by human cause, but I think the point here is that the dryness of the atmosphere makes it even more vulnerable to that kind of activity.
Excuse me.
Yeah.
Dryness of the atmosphere. Were you indicating that the research you've done here, though, actually showed that we're going to see more moisture, less heat, and more moisture in this area? Did I get that right?
So it's interesting. So what we're going to see is in the summer, we'll see generally a drier, hotter summer.
Oh, okay.
But as that heat, the impact that heat has actually is the air expands, more water gets absorbed into the atmosphere, and then what we're seeing is that gets dumped onto us in an increase in intensity of storms. And so I think your overall precipitation will increase, but you'll see less in the summer and more in the autumn and the winter. And usually it's extremes.
So some folks that I talked about seemed to know what they were talking about when we were talking about forest fires. Mm-hmm. So in our emergency meetings, our high-level executive emergency meetings that we have, preparing ourselves for, you know, what can Powder get hit by, i.e., you know, flooding is not really a big issue as much as forest fire. Mm-hmm. And they said, there was 3 or 4 things they saw that we had in our favor that the interior doesn't have. Is our timber's bigger, we have more moisture because of the ocean, where in the interior it's more desert-like, mm-hmm. So it's drier, smaller timbers, et cetera, and the mountains. And I went, the mountains? How does that help us? And they say, well, it keeps the clouds in, it keeps the moisture in, it's a break from the bad spot to the good spot, and these were some of the things that we had. If we still had a forest fire behind, it comes right into our city, because the wood's right to our back door. These were some of the things that they said why we see less than they're seeing in the interior. So we had some advantages being on the coast of not being as vulnerable. Would you agree with that?
I would agree with that, yeah, for sure. It's very different microclimates, and that's part of the challenge when we're trying to downscale for different communities is, you know, these big models, they look at kind of a third of BC, and there's so much variation even between Comox and here, because of the mountains and the sea and the cloud level and everything else. So it's really, it's really important to kind of downscale to something that's appropriate. We're doing some work right now with Capilano University in North Vancouver, and a similar thing, but they're surrounded by.
They also said our ability to have water really close was a good thing for firefighting. Yeah. Anyway. Yeah.
Do you know if anybody's modeling in our particular area the coast? Sorry, did I speak out of turn?
No.
Okay. How much of a pressure on our lakes and stuff there's going to be, or do we? Is that also a pocket thing we can't really predict that we need to actually?
That I don't know if anyone's modelling. I'm not aware that anyone is modelling that. I do know that Nanaimo has been looking at their water supply. They've also been looking at their sea level impact to their community and what that does. And actually, we've just started some work with them, and I was going to come to it later in the presentation, kind of just looking at a citywide scale. What are all of those vulnerabilities and how do you prioritize them? Because it's complex.
Comox Valley has for a number of years really been doing a lot more work on the hydrology of Comox Lake, which is a BC Hydro power supply lake, but it's also their water supply. So they're very concerned about the receding glacier and the reduced snowpack and how that's going to impact them in the future.
So then, and linked with wildfires is it's drier season overall, but then what we're seeing is these extreme short duration precipitation events. What that means is a heavy deluge, a storm event. And so this was a bit further down Sunshine Coast, it was at Langdale Ferry Terminal, after one of those events where it just washed out the lamp standard there and created all kinds of havoc just because of the amount of rain that came out in a really short period of time. And so although flooding may not be an issue, what you're seeing is these high intensity events that your system just isn't
Becoming more and more here.
And then that, obviously that erosion and landslides and other things that you perhaps haven't been aware of.
Excuse me, through the chair, I'm not sure, but I think we've had 200-year flood events in Powder River in the last 5, 6, 7 years.
Yeah. And so and I have a slide, a few slides on that kind of talks to that and how we take that into account. Drought, this is Chapman Lake, and you can kind of see the water level really dropping, and they're looking at what's happening there. So although there's not water issues per se, it is having an impact overall on the water quality and the amount of water, just because of the way that the precipitation is changing, as with the snowfall. And then the other thing is wind gusts, and what we're seeing is increasing intensity in the storms and the wind, and then power outages, and that has trickle-on effects. So your power goes down, and it affects treatment plants, or it affects other pieces of infrastructure that then you've got to try and get back. Your kind of gathering places in the community and other things like that. So, what can we do about that, or what are other communities doing, what can Powder River do about this? There's mitigation, and I think mitigation is pretty well understood, and you yourselves are doing a number of things on the mitigation front, and that's around sustainable transport, clean energy, reducing our GHGs, and then there's adaptation on the other side, which is kind of that resilience piece, redundancy, flood protection, maybe not necessary here, but there's some disaster management, what are you going to do when something happens, all that kind of stuff. And there's a whole bunch in the middle, which is both mitigation and adaptation. So bringing those together. So this is a really nice diagram that actually the City of Calgary put together, but I think it kind of captures those two pieces really well. And obviously, as I just mentioned, on the mitigation side, Powder River, you're doing a lot, and kudos to you for doing that. But we've got to look at adaptation, current and future, and just a couple of clips here from Surrey, which kind of re-echoes what we're talking about in terms of stormwater changing, and climate change related flooding, and the incidence of that increasing. And so when we design a facility, and all this image is trying to say is what we would try and do at a facility level or a project level is look at all of those extreme events and say, so how resilient is this project to those impacts? And we have been doing that with the wastewater treatment plant, and in fact I think it's a requirement of potential funding. And then to your point, Mayor, so what we have here is kind of this is precipitation specifically, and so what you have there is a 50-year event in red, a 20-year event in green, and a 10-year event in blue. And so you can see over time, the recurrence time for those things to happen is going down, it's trending down, so it's going to happen more and more frequently. And so when we're looking at a design lifetime of a project, your master plan might be kind of out 5 years, your roads out 30 years, your bridges, buildings 50 years, your kind of sewer system 75 years, something like that. So what does that mean when we're designing that as a project, when we're putting something in place that's going to last that long? How do we take that into account, looking at those increases in the occurrence of those big events? And I guess just to, and maybe, so this next slide kind of speaks to the approach that we need to take, which is a risk-based approach. And so sometimes we can say, well, if we do it at a certain stage, it's not going to be as expensive as it is down the road. Or conversely, maybe something isn't, there's some risk that you can manage rather than spend a lot of money to try and solve the problem. And so we need to look at it from a risk-based approach. So we can either build in capacity to adapt it later on. We can plan ahead to allow for things to be adapted later on as well. Or we can spend a little bit up front and put something in place that actually is going to have a huge benefit later on. And so this is from the United Nations, but it generally costs, it's a factor of 6. $1 now saves $7 after something's happened. And then just to kind of dive a little bit deeper, and I'm conscious the time is going on here, but this is something that we're using here when we're assessing our projects. It's called the PIBC, or Public Infrastructure Engineering Tool, but it's essentially a risk-based approach. And you can't see this, but you'll see it but along the top are all the weather events, and along the left-hand side are all the pieces of infrastructure in a particular project, and we're basically going to explore that at a project level and say, okay, if this weather event occurs, what's going to happen? What's the risk of it happening? What's the consequence of that happening? And how do we mitigate that either at the design stage or allow for it later on? And we'll certainly be looking at that for the wastewater. This is a snapshot of what we've been doing with Capilano University, literally just in the last month or so, as we've gone through their campus, and that's a campus level. We're doing something similar for the city of Nanaimo, but it basically kind of says, okay, this is what the piece of infrastructure that we're looking at, these are what's going to happen, and this is the recommendations that we would take to look after that for the future. And then just to kind of give you a snapshot of what's happening that I'm aware of, and I don't, I'm not, by all means, it's probably not an exhaustive list of what's going on or has gone on in the last couple of years with some other cities and municipalities. Nanaimo, as I mentioned, we're working through that. Langley have something going on right now, Kamloops, Kelowna, West Kelowna. So a lot of cities are starting to look at this in a structured way so that they can start to feed it into their master plans, their bylaws, and so they can think about this in a progressive and structured way rather than responding to it after an event has happened. And I'll just quickly look. So City of Nanaimo, this is really early stages. Essentially what we're looking at is all of their assets at a very high level, and then trying to work with them to prioritize what things need to be looked at first, what are the most high risk vulnerable things, and put a bit of a plan together. And then this will feed into their kind of overall master plans. Climate, the Cowie one, I'm picking on this one, not because it's a big city, but they've actually finished it and they've published some kind of high-level summaries, and so they're focused on power supply, redundancy, backup for extreme weather events, updated their design guidelines in terms of what developers should be using for storm events and things like that, and increased resilience. Stormwater management, and essentially kind of written this into their plans for their customers and their clients and their inhabitants. Flood protection, flood hazard mapping, they've updated their flood hazard mapping, they've looked at flood damage, they've looked at kind of mapping where that would happen and what impact that would have on their land use, and then also the quality of their water and what that would mean to their treatment plants and things like that. So they've kind of used that planning to filter through into almost every area of their jurisdiction. City of Surrey, this perhaps is not so applicable here, but they've looked at rainfall and what that might mean to their subdivisions, and how simple changes like putting in backflow presenters can really help the inundation that might happen under a flood. And so we done some modelling, and at low cost we looked at some various scenarios, kind of upgrading all the roads, increasing the kind of the pipelines, and what we found was the most effective was just putting in these backflow valves and vents and inundation of that. Conscious of time here, and then this is something that we worked with on Metro Vancouver, looking at their wastewater system as a whole and saying which pieces were the most vulnerable and what do we need to do in the most cost-effective way to improve that. And so we learned a lot through that.
our new wastewater treatment plant, how much room between the rising ocean and our actual plant do we have?
Yeah, lots.
Lots. Okay.
The site is, slopes down sort of from the town site at an average slope of about 9%. What we've done is we found, I think, a good job of the middle ground between where to put the hydraulics of the plant so that we can minimize the energy required to get the flow there. But in terms of the hydraulic grade line, is what we call it, the elevation of the water that's feeding down into the outfall system and the diffuser, I think it leaves the plant at an elevation of 12.5. Some of that energy is needed to drive through the diffusers, but 12.5 meters is above mean sea level now. So if you saw that increase by a meter or more, you're fine.
Question comes to mind following that up through the chair, and that is routing on the beach trail. We know that that's going to be fairly close to sea level. Do you have any comments or concerns?
Part of the beach trail is close to sea level. That's the section that's closest to Willingdon. We're not going into that section. We're going up through the municipal campsite and doing a directional drill of approximately 150 meters, sort of from the top of the campsite down to a point where we will intersect the trail, where it's wider and where the slopes on the upper side and the lower side are less severe, and that's how we're avoiding that section.
Thank you for clarifying that for all of us and the public.
Is there any of our current wastewater piping systems that we're not changing that are in danger of being impacted by rising water? Like that we might need to look at first and foremost in our plans for the next number of years?
I'm going to have to try to understand the question. Are there areas of your
existing
wastewater
piping
collection system
yes.
that are at a low elevation? So we have not looked at your system as a whole, but knowing the community as I do, the lowest areas are around the Willingdon Beach area. And there are, storm drains coming out of those municipal buildings and the museum and so on, but they flow into a pump station down at the beach, and that was recently fitted with backup power, I believe. Yes. So that's one area that we're not touching actually, but I think you'd have to talk to Tor about that. Then the other area where we know that flooding and high groundwater causes a problem is up at the Artaban area adjacent to Cranberry Lake. So that's part of what I talked about earlier when I was said that the city was looking for an opportunity to maybe get some grant money to help deal with that. So that's not a low elevation thing, but it is a high groundwater.
Currently, we probably have about 3 of our lowest pump stations are one at Grief Point Park. I don't know what the elevation is there, but it's a couple meters above the high water. Churchman's is a little bit higher. We pump up into that. War Street is one of our lower ones, and then the location of our the future location of our North Harbor pump station that's going to take over from the Westview plant. That'll be one of the low ones that we'll have to monitor over the years. But currently, it's a couple meters above the sea level.
Seeing no more questions, thank you very much.
I do have a couple more.
Councilman.
Back to the green roofs. I don't know who's can answer this.
Depends on the question.
Is it an extensive green roof as opposed to intensive green roof systems?
So I know what she means. Let me just explain. One has a higher soil mass than the other, so one is not lighter and thinner. Typically, and I always get them.
Extensive is the cheaper one.
Right, but it's usually like a cedar or a moss or whereas yours is full grass. I suspect, I don't know what we've allowed, is my structural engineer in terms of loading. So we've probably gone for the more intensive one.
Oh, really?
Just in terms of structural loading?
Oh, to allow for.
Yeah.
I mean, the intensive green roofs typically have like irrigation and different types of plants. Like, I don't think we need that.
Yeah.
So there was a lot of concern earlier when our director of planning sort of threw out there that these green roofs were being priced out and they were going to be really expensive. And I just said, you know, we could do extensive green roofs, which are not as pretty, but they don't need to look as pretty. They look like a field. So they're less load, they're no maintenance, they're just simple. So I just wanted to see if that's what we're kind of looking at.
Yeah, I mean, that makes, we come both. And honestly, quite often the intensive ones, because they need maintenance, and they end up being the same.
They end up getting ugly eventually anyway, because nobody wants to maintain them. So the extensive, I think, would be our preference, because they're a lot less expensive. And my other question was, if there's an I don't know what this type of treatment, whether there's an opportunity to do some methane capture down the road. If Fortis has been tossing that idea around for a while. I approached them at a conference last year, and I think at the time they came back and said there's not enough volume for the methane, but where do you?
Initially, that's they did have a cursory look at it, and that was the resultant. But recently, we're in touch with Fortis again. They've asked for our flows to the plant, and they're going to review it once again.
So there is an opportunity if Fortis will entertain us to do some methane capture and reuse for energy from the plant.
It's very, very early at this stage.
Right.
We've just passed on the flows. But they are when they were told that we are planning to build this plant, that they were interested.
Yeah.
So now we've provided those flows. We'll let them take a look at it, and we'll get some feedback and move on. Tom?
If I may, through the chair, I was in contact with Fortis, and in your presentation I saw a lot about anaerobic digestion, right? And I know that if we want to create methane, we need, in fact, anaerobic process. So is that something that Fortis could help us add in the future, or how would that work?
Yeah, great question. I was probably just going to answer that question. There is kind of a fork in the road when it comes to deciding which way you're going to treat your wastewater residuals. So what we were talking earlier about sludges. And the fork in the road is anaerobic, which is the family of processes that don't use oxygen, that instead of creating CO2 and that kind of thing, create methane. And Fortis and others are interested in methane, obviously. But those plants that use anaerobic processes have a different footprint, let's say, when it comes to odor potential. So when we looked at this situation and the scale of the city, 15,000 is on the lower end of viability for anaerobic processes, and then also just the proximity of the site to the town site and so on. When we looked at it, we made a decision to go with aerobic processes because of the much reduced odor potential. And from an anaerobic perspective, I think we've had this discussion a few times. Anaerobic processes require heat in the wintertime in order to operate. So sometimes what happens is in the wintertime you're burning the methane that you're producing to heat the process that's required to keep the process alive. And in an ideal scenario, you would have enough gas to do that winter heating, and then in the warm season the gas would be extra, and you could treat it, and Fortis could take it, and so on. What can happen if you don't have a large enough waste stream is that you can actually find a situation where you're having to supplement that by buying natural gas in the winter to heat your process, to keep it moving. So, Powell River is sort of in that range. Technology, as it improves, it probably helps smaller communities to be viable, but you're at that end of the scale. You're not at a sort of 100,000 person community where you're solid for producing methane.
So if we ever got big enough that we wanted to take our aerobic areas and turn them into
Anaerobic digesters, yeah.
No, the water treatment, like.
Oh, sure, expand your.
And then you, instead of building
Sure.
aerobic, you would build anaerobic. Would that be an
Sure.
easy transition then, or? You both got more volume and more people.
Well, anaerobic digesters are complex. They're expensive. It would be a transition. It would be, you'd look at it with the technology that's available at the time. I don't want to characterize that as something that would be, quick and cheap and easy. It would be a big transition.
I just mean if you're building new solid treatment anyway,
Yeah.
you could change at that point.
Yeah, you could. It would cost more, I think. It's fair to say, than adding more aerobic digesters, but you'd want to look at it at that time and make that decision at that point.
Councilor Paul?
Yeah, in light of the, through the chair, in light of the presentation here today, one question comes to mind for me, and that is, with all the processes and mechanical aspects of the facility, is that going to call for staffing 24/7, or are we going to get away with the regular hours that we're running now?
Our feeling is that it will be regular hours. What will happen though is, because of the complexity of this plant, will require a level 3 operator, and more than likely a second level 3 operator. We currently have one, but that may change, so that we always have to have a level 3 when we are on site. We have to have that certification. So that's what's going to increase, not necessarily manpower at the plant.
Thank you.
Are we able to get like a 1 to 2 minute flyover of the thing captured that we could share, like for anybody that wasn't here today?
For our website, you mean?
Yeah, like just capture like one kind of fly through 1 minute kind of just overview of the project.
Yeah, sure. Brett asked me if that would be something that we would show here, and I told him no, because I didn't want to have it look glitzy for you guys, basically. So, but what we could do is easily put one of those together, and you could put it on your website or use it as you saw fit. Absolutely.
That would be great. That would be great.
Through the chair, I have to leave. I've got those clients that need me late. They're ready to be picked up at their hotel. So thank you very much. Thank you very much. Great job.
Any more questions? Maybe we'll go to the press. Mr. Glinski.
I have no questions, Mr. Chair.
Shaw? Questions from the floor? Mr. Weaving.
Yeah, last year, I think it was May, I gave a presentation here at City Hall. Mr. Robinson was there. I think, Tor, you were there. Karen Skatshine, who had the file at that time, and some others. So what I presented was about 18 ideas that revolved around viewing it as a community asset and how to develop it as such, trying to get community buy-in. And I left that with Matt Fraser and others to view. I'm wondering if any of those ideas are going to be used, or ideas like that.
Chair, I don't believe I was at that meeting, Dave. Was that in this room?
No, the back room here.
Oh, okay. I would have to see your list and look at that again, Dave.
You weren't provided with that through City Council?
I can't say I was working on it.
Dave, that was a meeting, was that a meeting here in council?
No, it was in the conference room in the back. It lasted about 2 hours.
I think I remember that.
Mayor Formosa was there and others, Karen Skatshine, Tor was there, Frank was there before It occurred before he retired.
Provide you with think I remember seeing that list. To provide you with an answer, I think we need to go over that list again. It's been a while since
Well, I
we've
can
even
provide
looked at
council
this,
with a list. If I may, another question. After that meeting, I had a meeting, Elizabeth and I did, with the mayor discussing architectural design and the appearance of it. And I went out and took pictures of various buildings in town site that Mayor Formosa agreed upon, and I sent them along to him. He wanted to send them along. He told me for sure this was the ideas he was comfortable with as well. He was very enthused about it. Any comment that way, Tom?
I mean, with the design elements, we took as much input as we could. We took obviously direction from council. If there's something that is distinct that we're talking about right now, I would look for something that's more. What's the term? I'm looking for exactly what you're after. I'm not really sure.
Well, I can resend those pictures.
Well, no, just in general terms, like we're talking 18 elements. I'm not sure which ones we're speaking of.
The pictures I sent were the ones that Mayor Formosa asked for, to do with roof lines and that type of thing, to do with the buildings that are going to be built and what they're going to look like on site.
So are we looking for more heritage looking, more
Yes.
looking, higher,
yes,
lower?
in the recent
wider?
handout, I have here, I think it's point 8, you're mentioning using the school, the high school, Brooks, as a design cue for the buildings
That
down
was,
there.
yeah, one of the.
Yeah, it strikes me as a little funny because what you want to copy is right next door to Brooks. Why copy Brooks? That's a 1980s sort of version of, it's not that Brooks is an ugly building, you work there, you know it to be a very nice building, but it's not exactly town site, is it?
So is this input that went into the meetings where they tried to decide on the theme, or was this post deciding on the theme?
Yeah, we were discussing the mitigation of the looks and how to get the community to buy into it, how to develop it as an asset for the community.
So I was,
Different designs.
yeah, so I was under the impression there was a process where input was gathered, they did a bunch of different themes, and then they decided on a theme. On 2 themes?
This is
Okay.
post that.
Okay,
In May, there was a 2-hour meeting in the back room here.
okay.
Yeah, and I presented it, and it was written down, copies were taken.
If I can provide you with a bit of an answer, there was a lot of conversation. Today we really have looked only at process. In some of the renderings, I can see influences of those conversations, so I think your suggestions have been taken into consideration. I don't think you're going to see carbon copies of some of the suggestions that you...
Well, no, it
But
doesn't.
I can say I believe I saw influences. However, that wasn't really what we were looking at today. And I
Well,
think-
when will we be looking at those type of things, Don?
I work on behalf of the city. I'm going to have to defer to the city for an answer for that.
Okay, then, as chair,
We'll get back to you.
will there be a public process there yet again for that? or-
If I might add, we're quite far down the road. We've taken that input. We've looked at direction from council. We've provided some options, and this is in keeping with probably our last council meeting, the design of these buildings. So again, then we would look for council direction if what we've shown here is differing from the direction that you provided us. And I'm not aware of what those differences are, but if council can provide that to us, then by all means, we welcome it.
Yeah, I think you hit the nail on the head, Mr. Bartig, and that is we chose the natural vegetation or natural look theme, and that's what's come back.
We've heard, a number of options. At one point, we were going to screen the building with trees because nobody wanted to see the building. And then we were going to go to, to heritage or this look and that look. So we took that direction, and if there's something that council wants us to make a turn on, then by all means.
I think one of the guiding factors here is cost as well. So I think we can look a little more into your question, but I think we did take into consideration your suggestions. I remember it goes back a little while. Councilor Hathaway?
So in the interest of costs and whatever, good ideas, but in my opinion, that ship has sailed. We had the two, we chose one, we gave direction. They've done a whole design around our direction that to go back and revisit it and redesign it is going to be a
It's
huge
not that I
cost.
presented the ideas, it's the ideas themselves. I don't care if somebody else can present the ideas. Good ideas are good ideas, and it's to get community behind it and viewing it as a community asset rather than just a method of disposing of human waste, right? There's a lot you could do with this. This is going to be the largest expenditure probably in the history of Powell River. So if you include an extra $500,000 to make things more of a community asset, that would be prudent over the life of the facility. It's not a big deal.
Mr. Burdick.
Again, we can point to the process building. Maybe we can bring that back up on the screen, the process in the admin building, and give direction on how different we are from what that vision is. We believe that we're building a facility that is very fitting with the area. It does have some architectural flair, and as well deals with the process so that we can meet our regulatory requirements.
So with respect, I'll just add one comment. Aside from the green roofs, you'll notice that the exteriors at this point are very plain. It's because we're waiting for the architect to provide their surface treatment to the exteriors.
And that applies to the buildings as well?
That is the buildings I'm talking about. Yeah.
So to me, it seems to boil down to cost and risk. And we discussed this last year when you were here about those large vats, and I'm not sure the diameter of those vats, but I'm struck by the proximity to students, 400 students or so, and staff at Brooks and the neighborhood, and the fact that there is sludge in those large vats, and insects, migratory birds, that's on the fly route. And we had talked about a fine mesh screen. I know it's cost, but we're also talking health risk and long-term health risk as well as short-term. So this, I don't know if that's a question, but it's definitely a thought. I don't know how big are those vats, and they have sludge in them, and they're being aerated. And there are insects, and there's this season called summer, which gets hotter and drier and longer. So, a mesh.
So, through the chair, I'm not sure the vats that you're referring to. I'll just
The
say
aeration
the large
vats?
tanks. Yeah. Okay.
The tanks, yeah, the aeration.
So,
There's 4 of them.
as I will say again, and I have on many other occasions, the processes that we're using are natural processes, naturally occurring bacteria that break down the organics in the wastewater. I believe on one occasion I showed, to help people to get comfortable with the proximity question, I showed a number of wastewater treatment plants in BC where clarifiers and aerobic processes are located close to homes and neighborhoods and so on. There's a whole slew of them if you go up and down the Okanagan Valley that are all plus or minus 50 meters between process tanks and balconies. The consensus is that there's really no negative issue. In terms of migratory birds, it's not uncommon to see birds on clarifiers. It's not uncommon to see birds in ponds. Birds don't necessarily choose the most pristine water sources to hang out in, and when they leave them, they're not the most pristine either. This is just sort of a fact of nature, and it's not really that different in a treatment plant. I think it would be challenging to find a link or a pathway between a bird that was visiting someone's backyard when they're doing a barbecue kind of thing. And I don't mean to be cynical about that, but this is just a reality. And in terms of other insects and that kind of thing, we one of the best ways to control that and to deal with that is with aerobic processes. We just don't see that these are issues that negatively impact the community.
So my second comment was also, Jason discussed microplastics, and this is a secondary treatment plant, correct?
Yeah.
And the legislation has not mandated yet tertiary treatment. But most microplastics actually come from wastewater treatment plants. And that straight out there is home to several whale, dolphin, porpoise, rockfish, salmon species. And I'm just wondering whether the discussion, and again, it's cost and risk, and why people come to Paul River, and what lives out there and what survives out there. What about tertiary? How does that play in with the game of preventing microplastics from entering the strait?
So through the chair, the word tertiary is one that I would typically avoid using in a context like this because it means different things to different people. In the Okanagan, it means nutrient removal. But in a coastal context, and the way I'm going to take the question, it would be tertiary filtration.
Right.
So what would we do downstream of the gravity secondary clarifiers to further remove particulate material? Now, we can safely say that the system as proposed is going to meet the regulations, meet them all the time by a healthy margin. But what I talked about in the presentation when I said that the plant has been done in such a way that additional processes could be added if and when they're necessary. This is what I'm talking about. So if it became necessary at a certain point to put in tertiary filtration, that can be done with membranes, that can be done with other systems. We would set about to do that either in the process gallery or some other location, but that's something when it comes to microplastics, for example. When there's an understanding and a regulation and some drivers to do that, and some technology with, hopefully some standardized measurement techniques and so on, that's when it would be, appropriate and necessary for the city to look at that. So we know that the plant will do better than your 3 plants individually and combined now, but it would be problematic for us to recommend an approach to go after tertiary filtration when it's significantly over and above the regulations and there's no clear understood linkage and benefit to that right now.
But that's,
just before we go forward,
Jason did
Mrs.
mention
Armstrong, if I could
legislation
interrupt
is
you,
moving
please.
that way.
I got to interrupt you, please. I'd just like to mention, Mr. Robinson, that the flight leaves in 1 hour, and I think the airline requires your crew to be there at least 45 minutes ahead of time. So I think it would be prudent, if you want to catch that flight, for your crew to pack up. I understand that you can stay, so we could carry on. I just wanted to offer you that option. And then we can carry on, okay?
Thanks.
In a minute.
I think 30 minutes is.
Yeah, half an hour is
Is it 30 minutes? Oh, I thought it was 45 now.
They won't let you on the plane if you're not, if
Okay.
you're less than 20 minutes. 30 minutes is fine.
All right, good.
Nothing to
Okay,
add, just
we can-
that cost, it would be interesting to know what that cost would be
Yeah.
on top of the cost that we already have mounting to
I
build
think our
this.
community actually has some experience with the cost with the Westview treatment plant here, and I don't think that may not be a question that Mr. Armstrong or and crew are prepared to answer, because I think it would be entirely paid for by the taxpayers of Powell River, not being a necessary element of a system according to what's required by regulation. However, that's just my view, and maybe you could answer that question as well.
Well, it's not required by regulation, but it is,
Exactly.
we are moving in that direction. And legislation is always playing catch
I
up.
can assure you, the questions came from this table here about microplastics. So we care about it. Just hold up and then see.
Tom, to you, so are you saying that the open tanks are, with the aerated system, that the open tanks do not contain harmful bacteria or aerosol pathogens?
I would say that when you turn the soil over in your garden, you're exposed to more than you would be when you're above a tank in a wastewater plant.
But that's fecal matter in a garden. Whereas, as you know, the wastewater treatment plant, you've got all the antibiotics, you've got all the pharmaceuticals from the hospitals, you've got the industrial waste going into the system as well.
But your question was bacteria, was it not?
Harmful bacteria, aerosol pathogens, and antibiotics, yes. Because when you're talking about insects and birds being a vector for transporting that type of bacteria, and you said that's sort of, so that's the question I'm asking you.
Okay, I was having a little trouble hearing you. You know, when you talked about pharmaceuticals and emerging contaminants, you know, no question from this side that you know, educating your population so that there's no materials like that are being disposed of in the waste stream is the best way to go. Unused prescriptions will go back, and pharmacies take that material. You know, that's the way to handle that one. Emerging contaminants in wastewater is another topic, and it's in fact the problem with that topic is it's not a single topic. There are thousands of different compounds, and there is not one treatment scheme that deals with them all. So we're left to find treatment schemes that deal with as much as we can over a broad spectrum and that kind of thing. Aerobic activated sludge programs, processes and systems are the way you want to go to deal with that.
Tom, I'd like to interrupt you just for a sec.
Sure.
I just want to thank your crew here very much for an excellent, amazing presentation that included an awful lot of stuff that we didn't expect. So thank you so much for coming.
Yeah, thank you so
Very
much.
much appreciate you being here and all the work that you put in to presenting far more than I think we expected.
We love the software, that was fabulous.
Yeah, and
Council, so you're aware, this is the paper plans, this is what it amounts to, and this is, so they've converted that into 3D, so it's a little easier to understand. But those are the design elements that they've gone through with a fine-tooth comb. So it tells you the detail and the attention to the problem that happened.
many thanks.
Thank you very much.
So, Tom, my question then is, with all these multitude of compounds, if you had an enclosed tanks, as say the current Westview is, you don't have that risk of these compounds, pathogens, bacteria being dispersed in the air, whether just through the air itself or as an insect or bird as a vector.
So through the chair, I respectfully disagree. I think once you enclose those compounds, you change the risks, and in some ways, it could be argued that you increase the risks. What we've done here at this plant, and I'm going to revisit that for you, is at the front end of the plant, the raw wastewater that's coming in, there is a design here and an effort here that, you know, really any third-party wastewater engineer that wanted to review that, the comment to me would be, okay, wow, you guys have really gone the full distance here with this plant. So I am very comfortable that all of the airborne odors and whatever is coming in the raw wastewater is being extracted from the air and treated in the odor control system. And there are many processes in that will catch whatever particulates are coming through with that flow. Again, once you get to the aerobic processes, you can mess with nature, but at the end of the day, it's hard to beat. Bacteria just have a way of going after things. And, it's true that some of the drugs, some of the compounds that we make are tough and hard for bacteria to break down. What a bacterial sludge process does do is it absorbs. It allows those compounds to adsorb. So not be absorbed into the middle, but it will stick and it will go with the sludge. Which means that it's not going out. It means it's staying with the sludge, which means that it's going through the digestion process, which means it's going through the land application process. But I'm not going to argue that those materials, that they're not persistent in the environment. They are, and they're a concern for all of us.
So my next question is, I had the opportunity to go to the Tsawwassen plant, and the concern that I had was, with the tanks, and as the water, I'll call it water, decreases, you've got sludge on the outside, and I was told in warm weather that does produce odor. So what automated system is going to be implemented or can be implemented so that those walls are on a very regular basis or constantly being hosed down to avoid the sludge remaining there and causing odors and insects and such to attach themselves to?
So, Chair, Ms. Colbeck and I go way back, and it was on my recommendation that she go to the Tsawwassen plant that she went, which was a plant that we built about 3 years ago. This plant's different in that the Tsawwassen plant uses a process that fills the tanks and then subsequently draws them down and fills them and draws them down. The wastewater flowing in that plant does not flow continuously from process to process. And so you do have the walls that are sometimes full and sometimes not. That's true at Tsawwassen, it's not true for Powell River. Now, having said that, it could be true at any point in time that your sludge digesters are not entirely full, but we expect them to operate at that full level. That's the way they provide the 28 days of retention time, which is what we're looking for. But there could be periods of time when you're looking at the sides, it's down a meter or two, it's a bit brown. I wouldn't say that on such a day, if the conditions were right, that you wouldn't smell anything from the residual on the walls, but it is something that the operators can attend to if necessary. But I would eat my shirt if you could smell that in the property line.
Ooh.
I don't know if that's technical language.
You're on camera.
So, Mrs. Colbeck, if I could just interrupt you for a sec. We have a couple more people in the gallery who would like to ask questions, then we can come back to you, okay? Mr. Short.
I have questions that relate to microplastics, and I don't know if you have any data on, I believe in the centrifuge stage where you extract the water, how much or what percentage of the microplastics will go into the sludge. And if I understand the process correctly, that's what's collected in the bins and shipped over the island at that point. What comes out of the centrifuges, the solids?
In the Westview plant, it's a press operation. It's not it's not a centrifuge.
This new system.
With the new system, currently,
that sludge goes into bins.
Yes.
And that gets shipped.
And then it goes.
Any data on the percentage of microplastics in the sludge versus what's left in the water? And then my other questions, comment relate to, I've read all sorts of studies that are done. There are ways to monitor and test microplastics in water. There was kind of the inference earlier that it's difficult and you can't do that. And also, I don't think, speaking personally as a resident of Powell River, I would urge the council to not wait for tertiary filtration, that this is an issue. I've read reports, I mean, we're different than the Great Lakes, but the Great Lakes, there were 100% of the local breweries were tested and had microplastics in their beer. There's microplastics in their drinking water. There's microplastics in fish. And maybe we don't have the brewery concerns or the groundwater solutions based on where our water comes from. But we do have, as was pointed out earlier, we are on the ocean. And I have a concern that we're just saying, oh, we'll wait for legislation. I think this is something that I hope and I would ask that with our consultants and the council and staff, we get on this, we pay attention to this, and we not dismiss it.
Thank you.
Through the chair, I mostly, I don't fundamentally disagree with what we heard, but I want to make one small clarification. There was an inference that it's difficult to measure microplastics because that's the reality. But the larger problem is even that there's no standardization. Nobody has agreed on how these should be measured. And so for us to be comparing one plant with another around the world and so on without a standard comparison, without a standard way that things are measured, it's, you can find it on the internet, but I would caution you all as to what it actually means. So when you see a plant where somebody has said, we're removing 90% of microplastics, everybody in our team here that would sit down, was with us today, would smile and say, yeah, okay, well, let's take a look at how you were measuring them, what size particles you were actually including, and how you went about those analytical techniques. It's a great story. I hope it's true one day, but we're not there yet. And so be very careful about those kinds of things. That being said, the decision about whether to bring in tertiary filtration and the decision around how much microplastics that will remove, that's at the city's discretion for sure, and we'll support you in any way you want.
Thank you.
Just one small question. When you're looking at trying to filter out a microplastic, are you looking at a certain micron size then filtration as opposed to a centrifuge?
Oh, we wouldn't use centrifuges for removing.
Yeah,
it would be some sort of filtration. Yeah. So membranes is one thing. Very fine. These very fine stainless screens are another. There's a cloth mesh. That's another system. But
the smaller
just
the micron, the more expensive, right?
But just to be clear, these are systems for microfiltration, not exclusively for microplastics. They are for helping jurisdictions that have to reduce their total suspended solids in the effluent down to numbers like 5 and 10. They're not specifically targeted at plastics, but obviously they would address some of that issue at the same time.
Councilor Bushman.
Yeah, just before you go back to Steve, I believe council did ask for if we could get an idea of how much it would cost to add tertiary treatment, because if we do get this huge grant and we can add it at the time of including it in a grant at the cheapest borrowing financing we can get, that is the time to do it. Not in 5 or 10 years when we're going to have to pay full price and full borrowing costs. So I think the idea that came from the Sustainability Committee was, can we get a ballpark estimate on what tertiary filtration being added to the system now, how much would that cost? Just so we know, because if, $2 million on an $80 million plan is not a lot of money at cheap borrowing and 70 or 80% grant funding.
I'm not aware of what the cost is, or if it, is $2 million okay, or is $20 million?
So that's why I'm asking.
Okay, yeah, and I'm not sure if Tom can readily answer that question.
Yeah, no, we'd have to look at that and work up a bit of a look at what equipment and how that would fit in and what that would be before we could really provide it.
So through the chair, that was a request from council to get an idea of what that would look like.
Okay.
Wait a minute, through the chair, I just want to clarify. I don't remember us specifically making a request from this council on any issue regarding microfiber. I believe something came forward from the Sustainability Committee asking for a study, but I don't remember this council weighing in and saying we have to have a cost estimate. Correct me if I'm wrong.
Through the chair, it was directed to staff from council.
Offhand, I don't remember that.
I'll look at the minutes, and while you carry on, everyone.
Mr. Short, one more, and then Mr. Richardson.
There are things that homeowners can do. We can reduce, we can stop wearing these kinds of clothing. But I just did a quick calculation. If there's 13,000, 14,000 people in the city, say 13,000, there's 6,500 households, and each household spent $200 to address this. That's 1.3 million. I think it's better to address it at the filter plant level than putting it back on the public. And there are educational things to happen, but I do think it needs to happen at the level of our wastewater treatment plant. And if it's 1.5, 2 million, I think compared to putting it back on the public, have them change their ways and then get 75%, 50% success rate, it's better to deal with it at the wastewater level. And I have heard, and I've had some experience with this, there are sand filter systems that you can backwash, and then you have okay, what do you do with the backwash water? But and it could go on and on. But there are systems, and I don't know if that's the ideal system, but I think there are ways to do it.
Well, all of these filtration systems backwash, and that goes back to the front of the process.
Council Paul, and
Get
then
my kids.
Mr. Richardson.
Yeah, just to follow up on the question of, when I'm sitting here and I'm hearing, let's have this and let's have that, the one thing that I have to say, and it needs to be said, and nobody's even approached it this afternoon because we haven't gone there, but when we first started, when I came in here 10 years ago, we started going down Liquid Waste Road, and we were initially looking at the mill. That price tag at that time was $15 million, if we could make it happen. And then we changed direction, we went to a consolidated plant, standalone, came in at $30 million. Now we're faced with $60 to $70 million. And nobody's asked the question today, how much that's going to add to my tax bill. But we have some answers on that, some preliminary answers. It's not pretty, because we have to borrow up to $25 million to make this happen. And that's going to go directly to your tax bill. So, we can say we want this and we want that, but in the light of day, we have to watch every penny and what we're doing here in a very cost-effective manner to go ahead for this community, because it's going to cost the taxpayers an arm and a leg just to get what was presented here today. And I appreciate your comments, saying we can do it if council wants, but be prepared for another hefty increase to your overall cost of this facility.
So I was here last week when the
Mrs.
tourism.
Mrs. Armstrong,
Yes.
I actually would like to hear from Mr. Richardson, and we'll get right
sorry.
back to you. Thank you.
Thank you.
Mr. Richardson.
Thanks. Back to an issue Councillor Doak raised through the chair to Tom, and that was when the weather gets warmer and can we get enough air to keep the bugs happy. The plant design, are the air blowers constant?
No.
Speed or variable speed?
Variable.
Thank you. So that might help to answer your question.
So through the chair, all of the systems, virtually all of the systems in the plant, with the technology that's available today to save energy, we don't just run motors at full speed and use all that energy. We don't need to, and the blowers are definitely one of the most significant operational costs in the plant. Aeration typically is, I'm going to say, between 35 and 50% of the cost of operating a plant. So we don't want to push more energy at those blowers than is needed to. So systems monitor the dissolved oxygen in the process and make sure that the blowers are providing what's adequate to run the process. And as that demand increases, the blowers ramp up, and as it diminishes, they ramp down. So that they'll cruise around on a day-to-day basis, meeting the need.
Thank you. Mr. Richardson?
Yeah, and if it's any comfort, at the mill, the clarifiers that they have there are at least 6 times the size is what you're proposing here, maybe even larger. And I have to tell you, over all the years I've worked there, I never saw a single bird land on any of those clarifiers. Nor did I experience working around those clarifiers any bugs. And I don't like bugs. Bugs love me. I've never experienced a single bug around those clarifiers. And no birds. I just thought I'd pass that on.
Thank you. Mrs. Hobart?
Mr. Anderson, when I was at the Tawasin plant, the noise of the blower was well beyond the street into the fields. So how is that noise going to be diminished when you've got residences within 90 meters?
That's an interesting question. I found those blowers noisy as well. I think when I was there, they were still doing some work. I think the cover was off one of them. I think the doors were open. I don't know what the deal was when I was there. So let's leave Tawasin for what it is.
But is this going to be a concern at this one? Because you've got multiple residences within 90 meters of the facility.
Right. So I'm particularly happy to say these are in a concrete bunker underground. And they're very well removed from the town site. You've got a lot of stuff between you and those blowers even have noise enclosures around them. So we'll be able to find things that will be wrong, but I don't think that's going to be one.
Okay, good. When the so the 3 doors in the plant where you've got where the tanks are, or not the tanks, but the containers are for the biosolids and
the roll-up doors.
Yeah. So when those containers are being removed, will a truck go into the building, doors shut, loaded, opened up to reduce the risk of odor?
No. When the bins will be offloaded, a truck will pull up to the door. The door will be lifted. You guys, does it drag it up with a chain onto the truck?
That's right. Yes.
So typically it'll be hooked up and be pulled out a little ways, and then pulled up and onto a truck, and then the truck will level. Cover will be put on, and then drive away. But the answer to your question is there's a strong negative pressure inside the building. So as soon as that door opens, basically, there's going to be, the rush of air will be into that building.
As a vacuum, so to speak.
Yeah.
So can the containers be covered prior to leaving the building?
Yeah.
Mrs. Armstrong?
I was just going to say, so you have costs and you have risk, and I think about Powell River needing revenue, and we brand ourselves as coastal by nature, and we sell ourselves internationally as coastal by nature. And I think if you look at risk and cost analysis, to put money into improved filtration to make this a more healthy, beautiful place to come to, I don't think it's a throwaway expense. I think it's really a worthwhile investment.
After you, through the chair, after you find out how much this is going to be adding to your taxes, I'm sure that you'll be in sticker shock.
We have to do a journal.
What is it going to be adding to our taxes, Councillor Bond?
Oh, yeah, you're right.
Pardon me?
What estimate of tax increase do you have at this point?
I think our CFO can answer that question. I'm not prepared to answer it specifically at this time. I just have some generalities around it. And we don't know the final cost. So.
I have one last question. Plan Monitoring Committee. Dave Wheatley and myself had met with, I don't know,
Yeah.
were you there? Anyways, the mayor was going to set up a plan monitoring committee, and 4 people were on that committee last year. When is that actually going to be implemented, and when are we going to be involved?
I can't answer that question. Can you answer that
So,
question?
there is no formal plan monitoring committee or what it's been called in the past. I think the mayor a couple times invited different folks to come in and spoke of it as a monitoring.
He actually had established a committee, and there were 4 members on that committee. And if I, correct me if I'm wrong, but I do think there's to do with the Ministry of Environment. I think there is something in the guidelines that there is to be a committee.
Yeah. So I might add, there is a plan monitoring program that is required, that the ministry requires. What that implies is once you construct and you get into your plan, it's a continual monitoring to ensure that your plan is progressing and moving forward as you laid out. So it's, it would be how you deal with your sewage. As far as a committee to deal with the aesthetics of the plant or how it feels within the neighborhood, that would be up to, I'm not sure what the mayor had set up in that case, but the other one is a plan monitoring that would come into effect after construction.
Okay, and I do remember the conversation, again, that goes back to almost a year ago now. So I think the best thing to do would be to ask the mayor about that.
Okay.
And maybe that could get going again. However, that being said, we haven't been granted the money yet for this. So this is preliminary. The whole, I mean, we're expecting it, of course. So it's not happening yet. Mr. Whitney.
Do you have a prospective date that the province and the feds will be letting you know?
I don't believe that we've heard.
I think we're getting an indication that perhaps around June that we may hear from them.
June? Thank you.
Is that the province or the federal?
Both. It would be, the funding comes from both entities.
Right.
So they're currently reviewing the applications. That's what we're aware of, but they don't have a final decision just yet. I think the input that they're looking for is to be completed in May, and we're expecting an answer shortly thereafter. So we're hopeful in June. But I think it would also be, some of the announcements will be tied to the federal election.
I'm sure we could carry on conversation after this meeting as well.
Thanks very much.
Any other questions?
Thank you for taking my questions.
Thank you for bringing that.
Motion to adjourn.
Motion to adjourn, Councilor Leishman, second. Councilor Palm, all in favor, unanimous. Meeting adjourned.